never knew. Finding the knowledge of the real world starts with the point of which has no parts. These are the axioms of life. And I'll take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say, I'll find the proofs in reality. 'Cause they were right, we know that they were right. Starting circles and lines alone, constructing the nature of what's known. Conclusions are clear and the evidence seen. This 3D space works perfectly. And I'll take my chances with the old ways, finding the proofs in geometry. And I don't care what all the sophists say, I'll find the proofs in reality. When all around you is sinking sand, you'll have a place on which to stand. Foundations were already built for you, so open your mind. And I'll take my chances with the older ways, hearing the words of what the ancients said. They say my words sound like sorcery, but there's wisdom in all honesty. Come go with me, open your mind. Come go with me, we'll find the truth.
Well, welcome everybody. My name is Amy, and we're going to have a debate today between MC Toon and WhatsApp. This is going to be a great debate. I'm excited about it. I hope you all are too. So let's get everybody introduced. I'm going to start with WhatsApp. WhatsApp, how are you today?
Very good, thank you. The question, how are you guys? Because the last time we met, we left a little too early, I think.
I think so too. I think you're right. I'm excited about this one because it seems like we have a little bit more time, so this is really good. So this is awesome. So yeah. And next up we have MC Toon. MC Toon, how are you today?
I am great. It's a good day. I don't have the time constraint that I did last time, so hopefully it doesn't go too long, but I won't have to leave quickly.
Excellent. That's great. I know this is really good, and I have extra time today too, a little bit. So this is really good. No rushing today. So I hear that you wanted to start first. What's up? And you had a presentation to do.
Yes, sure. So
Okay, if you want to go
the
ahead
idea
and.
was that last time I didn't have it, so this time
Okay.
I'm bringing something.
Excellent. So if you want to go right ahead and get started, take your time, and we'll get going right on that for you.
It's ready for the... So basically last time we established that we should talk about the mean sea level. And as far as I remember, we didn't really at the very core of the conversation that we had again last time. So this time I try to bring something that is about mean sea level measurement. So the very first thing that I think we should start off is, what does it even mean? So anybody who's listening could have a broad idea what is mean sea level in the first place. I brought two different definitions from Britannica.com and SearchWatch.com. They're basically, agreeing with each other that the mean sea level is a datum to which elevations and contour intervals are generally referred to. The other definition from searchwatch.org also explains it as an average height of the sea over long periods of time, usually a month or a year, the shorter term variations of tides and storm and blah, blah, blah. So the basic idea is that the mean sea level is only just a reference from which we are vertically determining the elevation, the height of something. Now, in America, in the United States and its territories, the mean sea level is determined by taking hourly measurements of sea levels over a period of 19 years at various locations, and then averaging all of the measurements. Now, the basic problem that you would have is, how would you determine that if you have various locations and they are differ at the very base of their calculations? But that's will be another problem that I'm going to look into. By the way, this is from an article from National Geographic, so I guess the source is quite respectable. Now, the real problem when they are trying to determine the mean sea level is that the sea level is always changing. And for that, they, come up with the idea to have a tide gauge that is trying to measure the hourly happening tidal wave differences that happens because of the large body of water moving up and down. And basically what you see right now, I'm not sure if you're seeing it, by the way, I haven't tested it yet. Everybody sees what I'm showing. Don't see anything.
No, I don't see.
Oh, freak. I had 3 slides already. It's showing for me that I'm showing it.
Does anybody else see? What do you?
Sorry, yeah, it's working for me.
Oh,
That's bad because then I'm gonna jump back because yeah, Bebo sees it, and you were seeing
okay.
it on
I
full
have.
screen,
Yeah,
right?
You
Not
have
just...
to refresh if you can't see it because it is working.
Yeah, I have it. I had to hit on the view live stream, so got it. Thanks.
Okay, no problem. So I'm gonna be starting it again, not the whole thing. I'm just gonna go through the basic idea that I showed some definitions from Britannica and SearchWatch. Then I showed a citation from National Geographic that was made back in 2011, by the way, regarding how they measure mean sea level. And then I'm here right now. Can you see that right now, Martin?
Yep.
Okay, good. So the image that you can see on the left is from psmsl.org. That's quite also respectable source for explanations regarding surveying and benchmarks and things like that. So what I was talking about is they are using a so-called tide gauge to measure how the sea level changes over a period of time. Usually that time is like 1 hour incremental, going up and going on for the years, as I explained it before. And after a certain amount of time, and it varies for every country, by the way, on the world, but I think in the US it's about 6 years they count in, and they try to average all of the different tidal measurements and then come up with an average to that. Now that the sea level going up and down and averaging it, that is what is called mean sea level. That's why it's mean. Yeah, so have to, I mean, one example from exact example for a route. That we could call it observatory zero datum. We can call it different things. They call it very different things, by the way. And it's from the UK. It's established in Newlyn, England. And the basic idea is that they are saying that there is a mean sea level that is establishes a zero value for measuring elevation, measuring height. Is that refers to something also, because you cannot just have a zero at some point, and that's something that it refers to is just a physically placed dot, basically, and that's what they call benchmark. And in England, for England, as far as I know, this is the only and the basic and the one that every other benchmark refers back to. This in Newlyn, it's sorry, I'm hearing someone.
I'm sorry, that
someone
was
has some.
that was my wife talking to me.
Okay,
Sorry.
okay. Oh, sorry. No problem. So the basic idea again that there is a root, a basic benchmark, observatory zero datum, they call it, and the Ordnance Survey maps are referenced. It's bold, by the way. So they made it up like, I don't know, I didn't even look it up, but a very long time ago, like 100 years ago, they established it. This is where it gets tricky, because when and after you have a mean sea level established, how do they actually calculate? Do they even calculate the elevation, or is it somehow measured? Now, when you look on YouTube, when you put it in the search bar on Google, how do they measure elevation or height? You will find like 99% of the time these kind of images going around, on which you can clearly see the mean sea level is drawn up as and diagrammed as a horizontally straight line. For example, this source that I'm having is I'm trying to find the FAO, sorry, because it's United Nations kind of source. I'm not sure about the name from the top of my head. Let me look at it. Yeah, so it's well, it's a little bit funny, but this is one of the sources that you could go to, and you will find firstly when you search for it on Google, a Food and Agriculture Organization of the United Nations. So I guess they have some kind of a department that deals with this kind of question altogether. And find here, for example, a description about leveling. Now, two kinds of ways to measure or calculate leveling. One is direct leveling, which is a measurement. The other one is the indirect leveling, which is more like a calculation. Both pictures are also showing the distance in between you, the observer as a surveyor, for example, and the object, and drawing a horizontally straight line in between the two. If you would go on, for example, another kind of source, mapscaping.com, which is a website for some guys who started up like a little business in 2018, and they are creating and selling minimalist maps based on elevation data. They also show the sea level, for example, in this very basic diagram as a horizontally straight line. Now, what I also found is from IndianExpress.com, which is kind of far away, but I wanted to include some other sources that are not Western based. This is from an article that is explaining how they measured the elevation and the height of mountains. They also refer every time to the ground as being horizontally straight line. And I included a little diagram right below the actual measurement that you would find on that article. That's the basic calculations that they are doing because we are dealing with trigonometry in this case. Trigonometry, you can and you can only use simple triangles, not spherical ones, not hyperbolic ones, simple Euclidean triangles. I have another source. It's from outdoors.org. It's basically explaining the same thing. How would you measure height of a mountain if you could only look at the top of it? It's also, of course, talking about the ground as being a horizontal level straight line. What I found, by the way, 2 days ago, now that was a funny one. I just included this for the fun, because these guys, the one on the right is like a comedian mathematician, supposedly. He has quite a big fan base on YouTube, and for some reason, he decided to make a video about the Alberuni method of trying to determine the radius of the Earth. And if you would look at that image, this is a screenshot from the very end of that video. They came up with the radius of the Earth as 875 kilometers. Actually went out on the street. They measured the height of a building from the ground by going at a certain distance from it. That certain distance they weren't interested in. They went a little bit farther away. They measured both time the angle of that you could have when you look up towards the top of the building. From that, they tried to determine the height of the building, and from that they tried to determine the radius of the Earth, and they came up with like a 90% error. So I think, yeah, that's all. I'm finished. So that's the basic presentation that I wanted to start off this debate with.
That was great. Thank you very much for that. That was awesome. I actually learned a little bit about some stuff on there too. So that was really cool. Thank you. So, was there anything else you wanted to say first, or should we just get right into anything else or
Right
rebuttals?
right now, no, because the first part should be only to present your
Okay.
first idea.
Okay. Okay. Sounds good.
Okay, so I was curious, where is there more where there's like measurements that you're going to show?
No.
No, you're not going to show measurements of mean sea level being flat?
Would you like to go into the part in which we are actually debating the already set topic, which is right now, what I presented?
I think that's what's next, right?
Okay, well, in a regular, like, proper debate, they usually present their own side, and then they go into a certain aspect of the topic, and they try to debate it. Asking if you have something to show before we begin.
Do I have something to show of measurements of the surface of water being curved? I showed those last time. I mean, I could go through them again. Yeah. I could go through them again.
No.
No.
I'm not asking for doing the same thing that you did already. If you don't have anything new,
so you could just go from memory then that I showed measurements of the surface of water being curved.
Sure. Yeah, I remember. Okay. Yeah, Jesse Kozlowski. Yeah.
Yep. Okay. So, and now you're happy to go into a back and forth on this then?
Sure.
Okay.
Excellent.
So yeah, it is great information that, and a lot of people don't know, mean sea level, like in the United States, is a 19-year average. And you showed some diagrams where they used a straight line for sea level, and I think you found that to be maybe compelling. It's just a diagram, though. It wasn't meant to display anything in relation to the surface of the water. It was just giving an illustration of how they measure the elevation. So now the people that do this survey work, the surveyors, they have their own jargon, and their jargon when they talk about the word level is that level is curved. That's the definition of level in the field of surveying. If you disagree with that, it doesn't really matter. That is their jargon. We don't get to define an entire industry's jargon. So then the burden would be, if you think that level is not curved, would be then to show measurements of the surface of water, which is what they're speaking of, the surface of water being flat. And you didn't do that. And from last time, I did show the surface of water being curved. So I guess you didn't bring much there. So anyway, what they do is they take these average measurements, and then they use that. Oh, sure, go ahead.
Okay, so because we had a private, well, a direct messaging with each other, right? And in that, I claimed that I'm gonna bring something regarding measurements of mean sea level. That I did.
Yeah, the elevation of mean sea level. But not whether or not it's curved.
I'm sorry, I have to cut in elevation of mean sea level is 0 as a value, so it doesn't make much sense what you just said.
Yeah, but you didn't show whether or not mean sea level was curved or flat. All you did was identify the height on the shore of sea level.
There is no height, it's 0.
Well, the height is 0. 0 is a height.
That's a reference point.
Yeah.
That's the root reference point to which every other elevation ever measured is referencing to.
Yeah.
That's it.
Yeah. So what do they do with that then? Once they have the height of the shore of sea level along the shore all around a continent or a landmass, what do they do with that? You know what they do with that,
Maybe
right?
then I wasn't really sure, because this is really a tricky topic, by the way. If you would look into it, you would find the information to be very kind of hidden. You would have to search for it. Now, how you should basically imagine what they were doing at the very first time that they were trying to determine the elevation of anything is that they literally put a physical benchmark, like a little brass bolt that I showed on the 4th slide, I think, at a certain point that was close to the sea. And then from that point, they were, with the tide gauges, they were measuring the difference from that point that the water gives to you, because there are tidal waves. Now, from that, they got an average, which they call mean sea level. What they do after that is that they arbitrarily, of course, conceptually, on paper, they extend horizontal plane, and then from that horizontal plane, they vertically measure the height and the elevation of what they are trying to actually measure.
Do you have some citations to that?
But all my citations were in the slide. That's why I showed you, for example, the citation from the United Nations website, or the National Geographic, or the other ones, that whenever you would see an explanation as to how they determine an elevation of something, they always assume the ground to be a flat horizontal line or plane.
Then show the citation where they actually say that they always assume the surface of the ground to be flat. That's the specific citation I'm looking for. Do you have that? That wasn't in your slides.
Written out with actual. actual words and with those words. No, I do not have that.
Okay, so you don't. All right, excellent. So I do know a little more about what they do with this vertical information. They put that into a vertical datum. In the United States, the older one is NGVD, National Geodetic Vertical Datum, NGVD 29. And they updated it in 88, and they called it NAVD, North America Vertical Datum 88. Both of those are ellipsoids.
I'm not arguing the
So,
horizontal
you're gonna
plane defined by the
cite
water level. I'm perfectly fine with
something as a vertical differential from a datum, and that datum is an ellipsoid datum, then you are not suggesting that the surface of water is flat. You're suggesting that the surface of water matches that vertical datum, which is an ellipsoid.
Okay, we are not talking about at that point regarding measuring elevation. You are only talking about that particular idea of the ellipsoid.
Okay.
Not how they measure elevation.
Okay. So I mean, it seems all you have is you've described how they measure sea level at one point, and then at another point, and then at another point, but you didn't do anything to marry together how surveyors deal with different points in the you know, there's multiple points along the surface or the shore of water that they measure. So you didn't actually show what they do when they have all of these different vertical elevations or the offsets of being zero, right? But
can you see my screen sharing? Is it still there?
I see it, yes.
Okay, great, because that's literally from Wikipedia, which website I do not like, and I do not really suggest anybody to gather their information from Wikipedia. But what I did find there is that
image is from NOAA,
on the page
not from Wikipedia, right?
I'm explaining where I found the image, not if the image was originally made by Wikipedia at all. But okay. Yeah. So it's the article on Wikipedia is called National Geodetic Vertical Datum of 1929.
Yeah, that's what I talked about.
So it's the NGVD 29.
Yes, which is an ellipsoid.
An attached image, that article. And as I see, even in here, it's not representing in the image sea level or mean sea level in any other way than a horizontally straight line, and from which they are vertically measuring an elevation.
So you think that this diagram, the drawing in the diagram, trumps the actual datum that is an ellipsoid. So the diagram that you found in Wikipedia completely ignores that both the National Geodetic Vertical Datum 29 and the North American Vertical Datum 88 are both ellipsoids. You're ignoring that and saying this diagram has straight lines, therefore water is flat. That's your claim?
No, water is flat by itself, regardless of what they are claiming about it.
Well, do you have measurements of that then?
I mean, of course, if I want to be precise, I would say that the surface of water at rest.
Okay, but do you have measurements of that?
I don't. This is you came up with the NGVD 29. I'm showing you an image from that. I showed you like 5 different citations and other explanatory videos, screenshots, and things like that, and they are all referring to the sea level, so the water level, as being a horizontally straight line.
So because the diagrams drew a horizontal straight line, we can ignore that the NGVD 29 and NAVD 88 are actually ellipsoids? Is that what you're saying?
Actually, well, in order to claim that it's actually ellipsoid, you would have to have a radius, I think, for that ellipsoid.
which of course they do.
At least two radiuses, by the way. For an
Absolutely,
ellipsoid.
the
But you have to have-
polar radius, and an equatorial radius. Yes, they do.
Sure. And what did I show you at the last slide? If you remember, as a joke, I inserted that one, but I'm going to show it again. So this is literally like a 3-day, but not 3, like 5 days ago uploaded video. They are doing the Albiruni. I don't know if you heard about the guy, Albiruni, determining
Yes.
the radius of the Earth. Yes. Okay. So this is their recreation for Albiruni.
Yeah. Are you suggesting that NGVD29 or NAVD88 use the measurement from this guy?
Albiruni. No, I'm not inserting.
Okay,
I'm just
so
talking about the DR.
it has no impact on this particular NGVD29 or NAVD88 ellipsoids. Do you have anything relevant
since you haven't
to that
mentioned
thing?
how they came up, since
Oh.
you haven't explained in any way the radius measurement itself, I went into explaining my part of it.
Yeah, so I think that the NGVD29 ellipsoid is based on the Clark ellipsoid.
Okay, so
Yeah,
Yeah,
Alexander
okay.
Ross Clark. So a
can you
lot
show
of
it,
the
or should I look for it?
yeah, it was published in 1833. I can put the link in the live chat for everybody to have a look at here. There it is. And I know you think that this is an advertisement, but it's not, because I don't get any money for it. So on my website, 6 measurements of the radius of the Earth, including the one from Alexander.
Don't say what I think. I will say what I think for myself. Thank you. I did not think that, by the way.
Okay. Well, you did say it. You thought I was advertising my website. So since you don't think that, I will gladly just say on my website at mctoon.net/r, you can look up the second one. There is the ellipsoids from Alexander Ross Clark. That's the one that the early United States ellipsoids are based on. And then typically the European ones were based on the Bessel ellipsoid, which is the third one on that list.
Okay, great. So we got ellipsoids, like the NGVD29 is actually an ellipsoid, no problem. What I did ask like 5 minutes ago is how did they determine it? How did they actually measure it?
How did they measure the ellipsoid?
Yes.
How did Alexander Ross Clark survey and get the ellipsoid? The radiuses?
For example, yeah.
Yeah. So, well, being a surveyor, he used surveying techniques. So they measure typically a length along a parallel and a length along a longitude, or multiple longitudes and multiple parallels. And then they multiply that using trigonometry, because once you know, say 1 degree of 360, if you know that length, you can just multiply it by 360. Okay. And then you know the entire, say it's a latitude, you know the entire circumference of that latitude. Then with some trigonometry, you can get the radius of the equator.
Okay. You mentioned parallel. What do you mean? What is parallel to what?
That would be a line of latitude is a parallel. Sometimes we use the word parallel instead of latitude.
I never heard that, by the way. Like what you just said, I never heard that. But parallel latitude lines.
Yeah, latitude lines are parallel.
Latitude lines are parallel. Now, the only geometry I would have heard about it, maybe, is the spherical one. In my understanding of the world, we are living in Euclidean 3D space. That's not concerning spherical geometry whatsoever.
It's not what?
In Euclidean 3D space, when you have a parallel, you are actually meaning 2 straight lines.
Yeah, but like I said, surveyors have their own jargon and techniques. So when they say a parallel, they are saying that lines of latitude are parallel, meaning that they are doing these things on a three-dimensional spherical surface. So if you don't want to do measurements on that, it doesn't matter. That's what they did. That's how they did their measurements. So when they say a parallel or a line of latitude, they mean it is a parallel. So it's a circle, it's a concentric circle that's parallel to the other concentric circles on the surface of a sphere.
Yeah.
That's what they mean.
Okay, I know what they mean. What I
Okay.
just told you is that we are living in 3D. Sorry, we are living in 3D Euclidean space. Now, the spherical geometry is non-Euclidean. It's spherical geometry. The two has no real connection to each other. What they have, I'm going to present that within 1 second. It's not going to be a presentation, just a presentation of one thing only. And the real problem is that when you are dealing with different geometry and you are using jargon, they're not going to match. So what you mean by parallel, you should always add that you are talking about spherical geometry kind of parallel.
Okay, well, are you aware that there are transformation techniques between Euclidean three-dimensional coordinate systems and spherical coordinate systems?
Heard about it, but I never seen it actually
Okay,
carrying
well,
out without any kind of error.
Well, it's a purely mathematical thing there. So it's just depending on how many digits you want to carry in your precision. But in high school in the United States, we cover polar coordinate systems and Cartesian 2D coordinate systems, and the methods to switch between them, to transform between them, is covered in high school in the United States. Typically, spherical coordinate systems and three-dimensional Cartesian coordinate systems are covered in a university, or maybe in more advanced math classes in the United States. But yeah, it's done. There's no challenge to do it. It's very well mathematically defined. So you can have any coordinate system and transfer between them.
That's a great claim. What I wanted to say regarding what I'm going to present is taking up like 2 minutes more. So if you would
Okay.
like to say something, just go on.
No, go right ahead.
I'm going to insert 2 citations within, again, 2 minutes.
Okay.
1 moment, please. Amy, so far, are we behaving ourselves, by the way?
Yes.
Okay.
No interventions needed yet. You're doing excellent,
Okay,
both of
great.
you. Thank you.
Thank you. So, can you see my live stream?
Yes.
So these both are, again, from Wikipedia. Again, I do not like it, but this is the fastest way that I have right now. In the section that is talking about geometry a bit, you can find on Wikipedia, again, non-developable surfaces. Now, one kind of a non-developable surface within at least Euclidean geometry, which we are in, again, I'm going to mention it again, we are in Euclidean 3D space. Spheres are having a non-developable surface. under any metric, as they cannot be unrolled onto a plane. But the basic idea that it's not developable. The surface of a sphere is not developable. Now that's exactly what I meant when I said that spherical geometry is non-Euclidean. Because spherical geometry is dealing with the geometry of the two-dimensional surface of a sphere. Now those two claims, those two fields of mathematics are contradictory right from the beginning.
Well, that's some straws there. That you can. Are you saying that you couldn't put something on the surface of a sphere? So, like, maybe I had a basketball. I couldn't put a stick a diorama building onto the surface of a basketball. Is that what you're saying?
Diorama building on the surface of a ball, no problem with that. We are dealing with
Excellent.
the Euclidean space.
Okay. And you could define the coordinate system of that basketball using either Euclidean or spherical coordinate systems, either one, and you can transform between them with the formulas that have been developed quite a long time ago. So what problem is there?
In between the two because of what I just presented?
You're saying you cannot transform between the two? I'm sorry. I think you're going to need to do a little better than that. Mathematicians will definitely disagree with you that there's no transformation between coordinate systems.
Without errors, without distortions, without having any kind of problems, I cannot imagine.
A transformation between coordinate systems is not a flattening of a sphere. So that bottom one isn't what I'm talking about when I say transforming between coordinate systems. You have a point in three-dimensional space in Cartesian coordinate systems, and you have a point in three-dimensional space in spherical coordinate systems. There are mechanisms using trigonometry to transform one coordinate, an XYZ, to a R phi theta in a three-dimensional spherical coordinate system. There's no problem with this type of transformation.
May I ask you to show me the two different coordinate systems, just to so I have a picture about it?
You want to know about the spherical coordinate system?
Yeah, and the Cartesian one or whatever the other one you would like to compare it to. Or, well, not just compare, but transform from one another.
All right.
Thank you.
All right. And so I'll share. I don't know if you have to stop sharing yours or not, but
I think we can both live stream. I mean,
yeah. All right. So there is on Wolfram Alpha, which is I would highly recommend going there instead of Wikipedia to get information on these types of topics. So here's a spherical coordinate system. You can see the center of the sphere is the origin, and you've got a radius that's going up to the right. You see that? And then you've got inside, you've got a theta and a phi, or phi, depending on how you pronounce the Greek letters. So that's a spherical coordinate system.
Okay.
Right? And then the transformation to a Cartesian three-dimensional, I don't know if it's in here or not, but there you go. Here it is. In terms of Cartesian coordinates, x equals r cosine theta sine phi, y equals r sine theta sine phi, and z equals r cosine phi. There you go.
We are determining points with angles.
Yeah, that's how you transform between them.
And multiply it by the radius. Huh?
Yes.
How would you... the real basic problem I have with that is that like can you explain further? Because okay, we have these equations, but what does it actually mean? Like I have a point in the Cartesian coordinate system, which I haven't seen a picture or anything like that. That's what I specifically asked for. But okay, how do you actually do that besides this? Because this is only an equation, a formula.
Well, this also has a picture of Cartesian. You see the XYZ in the diagram there.
Oh, sorry. Yeah. Okay.
Yeah,
Okay.
I gave you exactly what you wanted.
Z. What the? I'm already having problems because, as far as I know, X and Y should be perpendicular to each other, and then the Z should also be perpendicular to the horizontal plane.
They all are. Yes, they all are orthogonal to each other. But because it's being drawn
I do not
on
see that.
it's being drawn on a two-dimensional surface, you have to use a little bit of imagination.
I'm sure that the Y and the X axes are not perpendicular to each other whatsoever.
In this particular diagram, they are not, because it's showing the x-axis as coming out of the screen, but you can't actually have the x-axis leave the screen because the screen is only two-dimensional. That's typically how drawings are done in three-dimensional space on a two-dimensional drawing or diagram. This is common.
Yep.
It's common in high school. In America at least. I don't know if you had a math teacher that tried to draw a three-dimensional object on a two-dimensional surface before.
Many times, yeah.
Oh, okay. All right. So what was your question then?
Does the end of the sentence? Okay. So again, okay. You let's say you are going from spherical to Euclidean. Now, how and why would you do that if the first basic idea is that there is Euclidean geometry and there is non-Euclidean geometry? Like that's what I'm trying to say to you, that the spherical or the hyperbolic geometry are non-Euclidean geometries. So when Euclidean geometry is referred to as, at the very end, of course, 3D space geometry that we are living in, then why would I use any kind of other geometry to determine a certain point of, let's say, in anywhere in the 3D space? Why would I use another geometry?
Well, I suppose if you're standing on the surface of a sphere, it would be pretty convenient.
But that you can do in 3D space, 3D Euclidean space. There's no problem regarding that.
Well,
The
true,
problem
but
comes in when you are trying to develop a 2D surface of a 3D sphere, because you cannot.
Correct. You cannot flatten a three-dimensional sphere without distortions. But
That's
you
what
don't
I mean.
need to.
I wouldn't use it.
If you leave your coordinate system in three-dimensional space, you don't need to. If you're going to be doing things in three-dimensional space and you're doing something on the surface of a sphere, then it is significantly more convenient to leave it in spherical coordinate system than to move it to a Cartesian coordinate system, or Euclidean, as sometimes referred to, because it's easier to do things. For example, to calculate the distances between points on the surface of a sphere, the math involved in doing that using a spherical coordinate system instead of a Cartesian coordinate system is significantly easier. You use the Haversine formula when you are in the spherical coordinate system. I don't even know what the formula would be if to get the three-dimensional spherical distance across the surface of a sphere using XYZ. I don't know what that is. I've never looked that up, but the Haversine formula is, while it's got a good number of factors to it, it's not that complicated.
I don't know why you mentioned Cartesian coordinate system, by the way, because like that's the one that we are actually using, isn't it?
Because what?
That's the one that we are actually using in our everyday, especially
Is
when we are
Cartesian.
trying to
Yes.
Yeah.
Yeah. Why would I mention Cartesian?
when you are trying to talk about the spherical geometry. Yeah?
Well, we use spherical geometry when we talk about latitude, longitude.
That's what
Those
you
are
use, spherical geometry.
Yeah, latitude and longitude are spherical terms.
No.
You didn't know that? So by this diagram, so that there's actual
Yep.
the longitude in this diagram is theta. Right? Do you see the theta? That's longitude. And then latitude is actually a linear number instead of a degree number in essence. But you can use phi as your latitude here as well. It's 0 to 360 degrees. Typically, it's just done from the equator. So it's a little bit of a transformation to get from a pure spherical coordinate system. But that's what we use every day. Latitude and longitude are spherical coordinate systems. So why would I talk about using spherical coordinate systems? Yep. Because that's what we use.
Well, let me show something for my claim that I'm gonna make in a moment.
Okay. Now, while you do that, I'll just say if the Earth were flat, then typically the azimuthal equidistant map or the Gleason map uses polar coordinate system, not Cartesian either. It has the origin at the center. You have a radius, which in that essence is the latitude, the radius, and then your theta, which is the longitude. So either way, we're not using on the surface of the Earth, we're not using Cartesian or coordinate systems. I'm
really ashamed of the third time that I'm showing a citation from Wikipedia, by the way. I'm going to make that clear right now, but that's what I'm going to do. The image is probably not directly from Wikipedia, but that's where I found it. So as far as I know, this is a Cartesian coordinate system, and I'm literally only seeing an X and Y axis.
Are you sharing it?
Yeah. Am I sharing it?
I don't see it.
But one moment. Maybe now.
There we go. I got it. Yep. Okay.
So as far as I know, this is like a Cartesian coordinate.
Yeah, generally we don't use that on the surface of the Earth anywhere. We use latitude, longitude, which is not a Cartesian coordinate system.
Well, as far as I know, longitude and latitude are also two directions.
Yes, but they're not either. It doesn't matter if the Earth is flat or spherical. Never in either of those models is latitude, longitude a Cartesian coordinate system. It's either a spherical coordinate system or a polar coordinate system.
I don't know how that's a rebuttal to what I said, but I cannot see again a third dimension in a Cartesian coordinate system whatsoever. So
you've never, you can't imagine? Well, right on your Wikipedia page, it talks about three
because
dimensions.
It's called a Cartesian coordinate plane in the first place, so that's why I cannot imagine.
Let me just
plane is a 2D.
Let me just read to you from the Wikipedia page that you got that image from. One can use the same principle to specify the position in any point in three-dimensional space by three Cartesian coordinates. Its sine distance to three mutually perpendicular planes, or equivalently by its perpendicular projection onto three mutually perpendicular lines. In general, n Cartesian coordinates, any element of real n space, specify the point in an n-dimensional Euclidean space for any dimension n. So you can have 2, 3, 4, 5, 10, 1,000 dimensional space in Cartesian coordinate systems.
Great. what I was trying to dwell into is the using of maps, because as far as I know, that's where we actually do use longitude and latitude lines, right?
Okay.
So,
but
my
nobody
contention.
claims.
Yep.
Nobody claims that latitude and longitude are Cartesian coordinates. Nobody does. Unless you, maybe you do. Maybe you are the lone rebel, the maverick, who says that Cartesian, latitude, longitude are Cartesian, but nobody else does. It is either polar or spherical coordinates.
I was trying to say, by the way, and that's what I said, is that they are referencing a kind of similar system as the Cartesian coordinate system. So again, what I wanted to dwell into is the usage of the Cartesian coordinate kind of systems, like a map.
Okay.
Now, on a map, when we are, for example, trying to measure a distance in between 2 points, as far as I know, those distances are not measured in any way as a curved line.
It depends on
when you mention the spherical geometry.
Well, it depends on the distance.
Determining a distance in between 2 points, that's not what I ever used in my life.
Yeah. How long of a distance have you measured on a map? What's the longest you've ever measured? And then
back in school in geography class, I'm guessing thousands of miles. Like
thousands of miles in geometry class, or geography class.
Geography class, and with a legend, of course. Yeah.
Okay, and then you traveled these because you had to plot the amount or predict the amount of fuel that you needed for the course.
So I was told that those maps are precise.
Okay, so I don't know what your educational system was, but I can guarantee you that every one of those maps said it was a projection. So like your previous citation where it said that you cannot put a spherical coordinate system or a spherical object onto a flat surface. That's exactly right, and that's why they use a projection.
A projection that is knowingly any kind of projection is distorted, therefore is not used.
Absolutely wrong.
For example,
absolutely wrong.
Oh, yeah?
All air maps use the Lambert conformal conic projection, which are a distortion. And when they're doing long navigation, if they need to be precise, there are things that a navigator must do in order to deal with the errors due to that projection. But for most shorter range flights, they don't need to do that because the margin of error is fine. And for example, when they do an air flight, they always have extra fuel, but not too much extra, because if you land with too much fuel, then you need to dump fuel before you land.
So I never heard it before, by the way, that air maps exist just for aerial navigation. And the second thing that I did hear, by the way, especially for sea navigation, so naval navigation, is using huge local maps that are made up of smaller local maps, just, stretched on a huge, like literally, physically a huge fucking map.
Yep. Correct.
Local maps.
And all of those maps.
Yep.
Yeah, and nautical maps are a Mercator projection, typically.
I just said local map. Those maps, the naval navigation maps, are made up of local maps that do not conform to any kind of sphere surface.
Yeah, because you need to fold it up to have it flat. So they use a Mercator projection when they do nautical maps, and they use a Lambert conformal conic projection when they do air maps. So for example, the FAA has their sectional charts that you can get for free for all over the United States. And that's what the pilots who are flying around the United States use, is the FAA sectional charts. Those are Lambert conformal conic projections. And they all say that there is a secant, two secant lines, which is typically in the a third of the way down or quarter of the way down, and a third of the way up or quarter of the way up is where the secant line is. And that particular line has no distortion across that line. Between the lines, there's a distortion one way, and outside the lines, there's a distortion the other way. So when you're doing, the cool thing about that is if you're doing a flight that crosses diagonally across any chart, those errors equal out. And your margin of error is greatly reduced when you do that.
I'm gonna respond to that in a moment because I just realized that I should have been more clear right now, because in my mind I have already mentioned it like 10 minutes ago, but I should have mentioned it again, that what I'm talking about, local maps using usually, especially nowadays, by the way, aerial photography, they measure distances like a straight line in between 2 points. And that's it. No curve, no bending, no level being, not horizontal or anything like that. They are just literally what you do is measure a distance in between 2 points with a straight line. What you just said,
and that
error
that works.
correction
That works
for the distortion.
That works
okay.
fine. That works fine for regular navigation, especially VFR navigation, because the amount of fuel needed that would be in error isn't that big of a problem. And like I said, they always have to have extra fuel.
Oceans. Oceans, like literally going from one continent to another, it wouldn't make a difference, right?
Well, okay. The all modern navigation is generally using an app on an iPad or in the flight computer on the plane, and that all uses three-dimensional coordinate systems and the Haversine formula.
I'm not sure about that in that way, but okay.
Wait, you can verify that yourself, because you could look at any of the different software. Some of it is available for free, some is for pay, but they all have the same output. And you can look at the distance that is charted when you do that route, and it'll say it's this many nautical miles. Then you can use the Haversine formula yourself, independent of the software, to verify that the software is getting the same number for that distance. If you find it's an error, then I would love to find out about that.
Okay. What I wanted to also mention, what you lastly mentioned, is how did you phrase it? The errors that you would get from a projection of the Earth would cancel out?
Yeah, if you do a flight across an entire chart, an entire Lambert conformal conic chart, so typically top to bottom, not left to right, because the distortion above the secant lines, or say outside the secant lines, I'll say, and inside the secant lines are opposite each other, that particular flight, if it crosses diagonal, will tend to reduce the errors significantly, because the amount that they're off between the secant lines and the amount that they're off outside the secant lines is approximately the same. So your error then is reduced a lot.
That's dependent on the actual flight path. Now, if the actual flight path is not going through in such a way that it would cancel out the error, then I cannot imagine what you're even talking about right now. But
okay, so
and that doesn't happen, right? So
what do you mean it doesn't? It doesn't happen.
Flight paths are not straight lines ever in reality. That's not how you travel.
Yeah, well, they're curved over the surface of the Earth, of course.
No, it's what I mean is that even if you would say that that's a curve, that wouldn't be a single arc with a single radius. That's not how anything moves, by the way, and especially airplanes are not moving like that. They are trying to deviate from each other. If they would have like not a crash, but just a small distance in between them when they are crossing a certain segment above the Earth, or they want to deviate from a huge just became to be their weather problem, like huge clouds or something like that. They are not traveling in a perfect path in any way.
Well, yeah, of course. You plan your path, and then you deal with real life situations. like you said, weather, or sometimes there's a geopolitical reason to avoid an area, like people won't fly over, Israeli airlines won't fly over Saudi Arabia. So they don't fly over Saudi Arabia. They go down to that, fly over water. Or if it's too high, so for example, that planes don't like to go over the mountain ranges in Asia because they're very high, so they tend to go around. But that's a whole different thing. And even when they do that, they have waypoints, they plot waypoints, and the distances between each of these waypoints is calculated with the Haversine formula. If you disagree, then please do provide the formula that is the correct formula for calculating distances between points. Do you have the correct formula?
What I have is a contention that if they are working off from a projection of the Earth, then they would have distortions that you cannot count for, because that's the word. Sorry again.
Why could you not
distortion.
account? Why could you not account for them? What would prevent somebody?
In the first place? And if you could,
excellent.
then it wouldn't be called a distortion.
Well, it is a distortion, whether or not you want to call it that. It is a distortion. So how would you account for that? Well, if you know that between the secant lines, there is a mathematical quantity of distortion that you can calculate. If you really need to, you can. The nice thing is, though, like I've said, the distortions are small enough that when they do the calculations, knowing full well that there is a margin of error, they include in their fuel budget for the trip extra fuel, so that if those errors are there that are adding or reducing the distance, or they have to go around because of weather, or because they have to go to a different airport because there's a problem when they're landing, they need to include all of these different things in there in the what if amount of fuel, and there's formulas for how much they do that. So all that is easily dealt with, and typically it's done ahead of time. Before they take off, they have to have the flight plan.
If they include, and they always include, more fuel than they actually need, then that tells me that they are not trusting those mathematical equations. So
actually, they completely trust those mathematical equations, and they allow a margin of error.
Sorry, mathematics not give you any kind of error. 2 plus 2 does not equal anything else besides 4. Okay.
Yeah.
So if you have a good equation,
we're not
then
dealing.
you should get the right answer to your problem.
Oh, but yeah, sure. It is possible to do that, and when you use the Haversine formula, that's what you get. But when you're doing short routes on paper, which isn't commonplace anymore, most navigation through air is done with a software, and is using the Haversine formula, so the distances are more accurate. But when they were doing it just with Lambert conformal conic maps, they dealt with that. There were mechanisms and procedures that they used to deal with those things. So
again,
I don't
as
know
far
what,
as I know, yep, okay.
You are claiming things about navigation, but you have not provided any evidence, and it seems that you don't quite understand navigation. So if you think that the Haversine formula is wrong, then go right ahead and show what actual formula is the correct way to measure distances between points on the surface of the Earth. Lacking that, you don't have anything.
They're already done that, by the way, basically. Now, again, you claiming things like that shouldn't be a part of the debate whatsoever. So you standing up and claiming that you don't have nothing is kind of, below the belt. But let's move on from that. So,
okay.
The Haversine formula, what is it about? Could you just, vaguely explain it to me?
What is the Haversine formula? It's the formula used to calculate distances between points on the surface of a sphere.
So we are back again to spherical geometry, right?
You specifically asked me to explain to you the Haversine formula, which I just did.
asking if it's based on the spherical geometry.
Yes, it is.
But then we are back to the part that I already mentioned and explained thoroughly then later, that the spherical geometry is non-Euclidean. It's not in 3D space. Therefore, I wouldn't deal with it ever regarding anything reality.
But pilots don't give a damn about what you would do or not. They actually use the Haversine formula. It is a three-dimensional solution, right? The surface of a sphere is a two-dimensional space, and the distances between them can be calculated using the Haversine formula. That's what pilots use.
I'm not
I would never
arguing
use something
the horizontal plane
non-Euclidean
defined by the
geometry
water level.
for
Damn good
Perfectly fine.
thing
reality.
that you're not a pilot. So
Okay.
if you ever were to be, trained to be a pilot, you would figure out pretty quickly that you're going to need to use the Haversine formula.
So that's my basic rebuttal. Again, spherical geometry is not a reality whatsoever.
So you say.
Conceptual geometry.
Well, yeah, all
But
geometry
that's
is conceptual.
What I just said. Every mathematician agrees with that it's conceptual.
Yeah, all
That
math is
they agree
conceptual,
with.
yes.
That's why
And then you map it into meat space, and you find out that there's always a margin of
geometry,
error.
not mathematics.
Geometry is a subset of
This is-
mathematics. Are you unaware of this?
So again,
You have to know
spherical
that.
geometry.
You can't be confused that geometry is not part of math. You cannot be confused about that, can you?
Spherical geometry is conceptual altogether, not based in reality. The one that is based in reality is called Euclidean geometry.
Well, that would be a claim I suppose you could support by showing a supporting evidence for that, I guess. Go ahead. I'll wait.
The spherical geometry is conceptual. Sure.
All geometry is conceptual. It's purely math.
Maybe 2
That's
minutes
all that
ago,
geometry
you
is.
said mathematics is conceptual, and that's not what I said in the first place. But never mind. Now you're saying any geometry is conceptual. That's not really, by the way, because geometry, the word itself means metric of the geo, which means, geo meaning terra, or meaning the ground, and
Okay,
the
so
metry is
the
measuring.
definition
So
that you're
no,
going for the definition is all that it means everything. Then definition means everything, or
obviously.
or can we? Obviously not. Obviously not. Geometry isn't just because of the definition of the word doesn't tell us reality, right? Is reality Cartesian or spherical coordinate system? It can be represented with both, but they are all conceptual.
And geometry is Earth measuring, nothing else.
Really? Well, tell that to math teachers that teach geometry and don't teach Earth measuring during geometry class.
I tell you one better, they told me what I just told you. So
Okay, so all this is just, you're trying to get off into semantics and definitions, but the problem that you still have is that none of this that you have has any measurements to support it at all. And you want to suggest that mean sea level is flat, but you didn't actually show that. You just defined what mean sea level is. You want to say that somehow you would not use the Haversine formula to calculate distances between points, but in reality, pilots do use the Haversine formula. So it doesn't matter your opinion on it because they don't care about your opinion. None of them are going to ask you whether or not they're going to keep using the Haversine formula or not. They're going to keep using it. So do you have anything to support all of your points here other than just trying to lay down that geometry means measure the Earth?
That's a very good point in the first place,
Maybe
because
you have
may-
a measurement
may-
of the Earth.
can you
That would be novel.
can you not cut in every time?
Sure,
Like for the past 15 minutes you were cutting in. Thank you. So I'm gonna refer back to my presentation that I had at the very beginning. Can you see maybe my live stream?
Yes.
Okay. So the very basic idea regarding what you just said, for me at least, and as far as I can tell, for the measurements of, let's say, an elevation and the height of a mountain, is literally based within Euclidean geometry altogether, because
Oh.
that's where you have the form, the logarithm table for a triangle, from which you can determine, for example, based on a drawn diagram of the reality, the height of the mountain, for example. It's coming from Euclidean geometry altogether, not from spherical, not from hyperbolic, not from any kind of else geometry. Euclidean geometry.
And you're showing this, the citation, the
Am
supporting
I
evidence
not?
for the citation? It looks like you just have a diagram of Cartesian coordinates from. Is that still the one from Wikipedia?
I'm showing something else. If you see that,
Okay.
then you maybe have to refresh,
I
as
have
Emma
it
told you before.
spinning. Yeah, it's just spinning.
Okay.
I don't know how to refresh.
Okay, then I'm gonna do a stop streaming and restart. Ta-da.
Yeah, I see the preview.
Now,
For some reason, it's not.
view.
Oh, there it is. Okay.
Yes.
How elevation is measured. Okay.
So, what I said before, do you remember what I said for the past 3 minutes?
Yeah, that they use this triangulation and to
Kind
and
of. Well,
yeah.
you know, if we would want to go into the technicality, then triangulation means a little bit different thing, but this is also could be called triangulation because we are using triangles. I mean, at this point, I mean, surveyors do use, and they did use whenever they wanted to only calculate something because they didn't want to go such heights for, you know, obvious reasons.
Yep.
This one is, which one is this one? Let me look it up. I'm not sure if it's the Himalaya or not, but I'm gonna look it up. One moment. Oh, Mount Everest. This one is the
Yeah.
Mount Everest, by the way.
Which
And
one is?
in the article that the article, the image that I'm showing is from an article that is describing how experts measured a mountain's height. And in this case, they showed Mount Everest.
So you're saying this is
Again,
how you're claiming this is how surveyors do it.
Yep.
And the article will say
From
this is
time to
how
time,
surveyors
this
do it.
is
And this is how
this is exactly how they do it. Yeah.
When the height of Mount Everest was measured, this is the mechanism they used.
That's what the article is explaining to you. Yeah.
All right. Well, I hope to see Everest in there. 7103 688.
So that's my basic rebuttal, that they are using Euclidean geometry whenever they are measuring, for example, elevation. But that's what they use when they are trying to determine a distance to something. Also, that's when I was talking about the maps. You know, that's basic Euclidean geometry right there, without any kind of curving paths.
Can you put that link into the live chat?
Sure. Live stream too. What the?
Did you put it in? Oh, yeah.
Oh, not yet. Now.
Okay.
I was copying from PowerPoint and it wanted to copy paste in a PNG.
Sure.
I don't know why.
So, oh, I love this. All right. Let me.
This
So
is
that's
just, one example. I showed you again, 5 different more. I'm not gonna do that again because that was the presentation about presentation.
Yeah.
I wouldn't call it a presentation, but
all right. Well, let's read here. In a new measurement, China and Nepal have announced Mount Everest is 86 centimeters taller than the 8,848 meter accepted globally so far. How was the original height calculated by a survey of India? What does the revision mean? Two of the senior most officials of Survey of India explain in an interview to the Indian Express. That's fantastic. The basic principle was used earlier, and this very simply uses only trigonometry, which we're familiar with. Uh-oh. Do you want me to stop reading? Go away there. So, principle can be applied for measuring height of an object that does not offer convenience of dropping measuring tape from top to bottom if you can't climb top of a mountain to use a sophisticated instrument. Very nice. So this doesn't give a whole lot of detail, but that's pretty cool. There's no GPS or satellite in the 50s. Yep.
what happened
now,
in my, not just opinion, I'm almost 100% sure, is that what I'm showing right now in my live stream is the modern day Alberuni fence slide that I have. These guys actually did the same almost. They went out and they measured the height of a building with the same way. Now, what they did is trying to measure, an angle from their eye level towards the top of the building. Now, when you do that, and you do not have those referred sophisticated instruments, now that's when you have the error of, how much was it, 86 centimeters.
And that's a great lesson.
Nothing else.
Yeah, that's a great lesson because I've watched the whole video, and it was a rather sloppy measurement. It was comedy, like you said. He's kind of a comedian. He actually cut out his arm length things, put it onto a pad, and then stuck them to his shoes, and then walked along half a block along the streets of London. So the measurements that they used were very poor, and then they weren't able to actually bring the device that he made up into the viewing tower of the shard because they wouldn't let him bring that up there. So the measurement, the angle measurement, the dip measurement from there wasn't very accurate either. It was only accurate to 1 degree.
Not even close to accurate. Yeah.
So the lesson there is sloppy measurements give you horrible results. Garbage in, garbage out.
Great. So when you presented the Jesse Kozlowski thingy that you had, using a theodolite and measuring an angle. Now, would you ever think, at least, that Jesse Kozlowski did something at least again similar, and then not counting in any kind of refraction at all?
Well, first of all, to compare, from the top of the shard, their margin of error, their precision on the measurement was 1 degree, giving them a plus or minus 0.5 degree margin of error minimum. Jesse Kozlowski used a theodolite that's accurate to 1/3600th of a degree, giving the margin of error as half of that. But he did multiple measurements, giving a smaller margin of error than that. So comparing the margin of error of those two measurements is pretty interesting. Jesse's was very, very precise. Second, he did not, in fact, include refraction in his observation, but that doesn't help you. I think we covered this last time. Refraction causes distant objects to appear slightly higher. In order for the Earth to be flat from his measurements, then refraction would have to cause distant objects to be a good deal lower, which isn't what we see. And like I think I mentioned
Remember,
last time, there are many
it's a
previous measurements of the effects of refraction over the surface of the Earth in different environments, different temperatures, different times of day, different surfaces. On my website at mc2.net/refraction, there's a large list of refraction measurements. So if you do
you
want
remember
to
what was
include,
my rebuttal to that?
what your rebuttal to that was that you expected all measurements to have a zero margin of error, I believe.
No. That's what
No?
you said. I never
Oh.
said that, by the way.
Okay.
What you
And
said.
well,
What I
what is
said
your rebuttal
that-
to that then?
Well, the rebuttal, you just said like 4 different things, right? My rebuttal, what I was trying to ask you right now, was towards the claim that refraction would only make an image to appear higher than it is. That claim, I have, since then, by the way, I have never found a citation whatsoever for.
I second that.
Who's that?
Crooks, sorry, this is an event. Could you mute yourself for a little while?
Yes,
Thank you very
sir.
much. No problem. Thank you very much.
So, well, I did I not give you the citation last time to my website? Because there's a lot of opportunities for you to look at citations there of refraction causing distant objects to be appear slightly higher.
But your claim is that it always happens that way.
Yeah.
That I have not found anything regarding that. Even by the way,
Yeah.
the other part I haven't found anything for.
I'll say that it doesn't always happen that way, and I think I made that clear last time. There are conditions where you can have the vertical stacking of index of refraction go the other direction than normal, and when that happens, though, it's a very, very rare condition, and there are significant other effects in the atmosphere that are clear when that happens. Typically, you will see miraging, multiple layers of miraging. You'll see different optical effects when that happens. In normal conditions, we can just look at the observations and see that is likely not happening.
This kind of vague phrasing when you say it's likely not happening and blah blah blah. Mate, whenever, for example, as I said last time also, Jesse went out and made his measurements. I'm fine with that. But when he's trying to create a geographical physical form based on an apparent measurement, now that's where my problem comes in.
Oh, so all of your measurements must be a physical measurement and not an apparent measurement. I do remember that was from time. So do you have any of those of any sort?
No, mate, that's not the problem. The problem in the first place is that you think that there is always refraction, right? That was one of your points last time.
Absolutely.
And therefore you cannot take anything for granted, just like that, because there is always a refraction. Now the problem with that is that you seem to suggest that you are the one who is measuring something. Is that true?
That I am measuring something? No, Jesse measured it.
Okay, so Jesse was the measurement device. I have never heard that before.
What do you mean? Jesse was the measurement device? He used a theodolite.
Yes.
Do you not know that you can?
Is measuring, right?
Yes, the theodolite measured it.
So
what's wrong with that?
When you are saying stuff like you are measuring something, but you are also in the atmosphere, of course. Therefore, you have problems. It's not you who is measuring anything. That's why it's called a measurement, because we are using measuring devices for that, which will tell us.
Yeah. People know this. I don't know why we're covering this.
The huge fucking struggle regarding that last time.
Okay. So, what's your point?
My point is that the measuring devices are not wrong in any way. But what you are trying to do when you are measuring an apparent thing and then claim that the apparent thing is physical, that's nonsense, because you haven't measured the physical thing at all.
Yeah, but you don't have any measurements of the physical yourself to offer.
The best way, in my opinion, especially, and I'm looping it back to the very beginning of my presentation, is the mean sea level. Now, you could call that sea level. Also, you could call that water level. My device would be a water level.
Okay. And how would you look at two distant water levels to see if they're at the same plane? How would you do that? How would you determine if two distant levels are the same?
Distant levels, you mean one end of the water level and then the other, right?
Let's say you set up along the coast of some landmass, 100 miles long or 10 miles long. How would you determine the relationship between the different water levels to see whether or not they are in fact on the same plane, or if they are on something other than the same plane? How would you do that?
Since we just established that just by looking at something, especially that is over a distance of miles, we couldn't determine anything because we know it's just an apparent, and it always changes. No matter how you can claim that it always changes in a way that it actually rises from the physical point. Like that's what you actually claimed like back a few minutes ago when you said that it's the best atmospheric refractions are only rising the image. Therefore, the physical is actually below always than what you see. Now, that's complete nonsense in my opinion. But the other thing, again, how I would measure it is just by logic. If we claim that the horizontal plane is established by water at rest, which is the mean sea level, which is coming from sea level, then I have my proof.
But how did you determine whether or not the surface is curved or not? How did you measure that?
What?
The surface of water. How did you determine that the surface is curved or flat? How did you measure that?
It wasn't me, by the way. It was surveyors
How did
to use mean sea level as a horizontal plane for the reference of the elevation measuring.
But they put it into NGVD 29, which is an ellipse, or NAVD 88, which is an ellipse. Doesn't help your point. Those are ellipses. Those are curves. They put those into curves, not planes, curves. So how do you think that the surface of water was determined to be flat? How did that happen? Where are those measurements? Because you can't go and claim NGVD 29 shows flatness, because it is an ellipse.
Wait, the NGVD 29 is just a diagram. It doesn't show anything.
It's not a diagram. NGVD is an ellipsoid datum. It's an ellipsoid. It's mathematical datum.
Datum is actually the benchmark in physical reality, by the way. That's the vertical datum. I was trying to be very explicit and clear about that in my presentation, by the way. The actual vertical datum is a benchmark in reality. It's physically right there. What I showed you, England Union, there is a vertical datum that is called a benchmark, and that's what the benchmark is, and that's what the vertical datum is, not an ellipsoid or a drawing of an ellipsoid in any sense.
Okay, so how did you determine that it was flat? How did anybody determine that it was flat? Because there's a diagram? Because the diagram has a straight line on it? Is that how you determined it was flat?
The claim is
the benchmark.
Right. Who was interrupting there?
You mean the benchmark? If the benchmark is flat,
hold on a second. Hold on a second. We have somebody interrupting.
Yeah, sorry about that.
So,
Can whoever that was please mute? Thank you. I appreciate that.
All right, so I didn't hear your answer. I'm sorry. How did you determine that it was flat?
I asked you, what do you mean by it was flat? What was flat? The benchmark?
Well, you seem to think that the surface of water is flat, and I'm asking, and then you referenced mean sea level. How did you determine that mean sea level was flat? How was that done?
It wasn't me again. It was the surveyors themselves who claimed
I don't care.
that the mean sea level establishes a horizontal plane throughout the continent.
Where does it say it establishes a horizontal plane? Bring that citation up where it says it establishes a horizontal plane.
In every image that I showed in my presentation,
none of those
referring to mean sea level.
None of them said
straight line.
None of them said it establishes a horizontal plane. It just had a diagram.
Or they just show you. They just show you, I think that's better, by the way.
So if a diagram is all we need, then I got lots of diagrams that show the surface to being curved. But diagrams aren't reality, right? Measurements is how we figure out what reality is. So do you have anything from reality, measurements of the surface of water being flat?
Do you remember why I brought up the Albirun in the first place like half an hour ago? I asked you when you were first mentioning the NGVD 29, how the radiuses were actually measured.
Yes.
Then I haven't heard an answer to that, by the way.
The answer I gave already,
but I haven't heard.
Yeah, you seem to forgot Alexander Ross Clark's ellipsoids, 1933.
That's another ellipsoid. I asked for measurement, and could you explain it then?
And I pasted the link to his publication in the chat. And if you want, I can bring it up and we can start looking at it. But it's certainly a lot more reading than would be useful to do during a debate like this.
These kind of measurements are not that hard to explain, especially vaguely, and that's what we are trying to do here. Not you, neither we are professors at a university right now. We are just talking. So.
Yeah, I'm just referencing the measurements that other people have done. So I put in the chat there the Alexander Ross Clark 1833. It's called Account of the Observations and Calculations of the Principal Triangulation and the Figure, Dimensions, and Mean Specific Gravity of the Earth as derived therefrom.
Okay, but again, what I'm interested in is how the measurement was actually carried out. What is the basis for it?
And I covered that both last time and already today, but I'll do it again. They measure sometimes multiple, sometimes just one, longitudes and latitude lines. Then they use trigonometry to get the radius, the circumference of that particular line of latitude or line of longitude.
What do you mean by measuring lines?
A line of latitude. Do you know what a line of latitude is?
It's a great circle altogether. So what do you mean by measuring
a line of latitude is not a great circle. Lines of longitude are great circles. Lines of latitude are parallels.
Right about it?
Yes, they're concentric circles.
Well, in your model, by the way, it is, isn't it?
It is what?
It comes out as a great circle.
Longitude.
Geometry.
Yeah, lines of longitude are. Lines of latitude are not great circles. Just the equator line of latitude is a great circle. All the others are not great circles. So you measure a portion of a line of latitude, say 1 degree to make it easy, and you find that it is a certain distance. You multiply that by 360. That gives you the circumference of that particular line of longitude. Then simple sine cosine, you can get the radius, the circumference of the equator. So that would give you the equatorial circumference, which you can get the equatorial radius. Same thing for a line of longitude. You measure a certain portion of it, say 1 degree. Multiply that by 360. That gives you the circumference of the entire line of longitude. That gives you the radius. So that gives you your two radii, the polar radius and the equatorial radius. That's how you get them.
So then it's a great circle, isn't it?
Only the lines of longitude are great circles and the equator.
Let's just say I was right, okay? Just because you couldn't get it the first time, I was right about that, okay? Now, the problem is that you are representing something that you think that it should work in that way. The very first thing is the longitude line is actually the circle. When you say circle, it's 2D to me. Not in any way.
It's a circle on the surface of a sphere.
Circle, it's 2D. The 2D shape.
Wouldn't it be a straight line on the surface of a sphere?
I'm going to mute him myself, so I won't hear him in the future when he interrupts.
Yeah, if you just give me a second, I'm not sure who interrupted or if you know what's going on here, but everyone is not to interrupt.
That was Crux Ader.
Oh, is there no talking? Y'all pause.
Yeah, no talking. Yeah, that means go on mute. Yeah.
Yeah, sorry about that. There's a debate going on. Thanks, Rakia, too.
Thank you.
So a circle, which that's what lines of latitude are, is concentric circles. So you asked how they got the radius, and that's what I explained is how they measured the radius when they're doing these triangulations.
Every circle has a radius, no problem, but it's still just 2D, and I'm agreeing with one of the circles that you have, right? I'm not agreeing with the other one having as a plane and as an angle. Cool. That's what I'm not agreeing with at all.
Okay. Well, you asked how they measured the radiuses. That's how they did it. So if you disagree with how surveyors do their work
in 2D, that's what I'm telling you.
Yeah, if you disagree with how surveyors do their work, I suppose you could go read up how they did it and go to different surveyors and say, you're doing it wrong, right? If you disagree with how they do it, but that's how they do it. And they've been doing it using similar methods for hundreds of years. So that's you asked how they did it. That's how they do it.
Explained with citations what surveyors do in my presentation that happened, I don't know, more than an hour ago. So.
Actually, none of your stuff was directly talking about how surveyors did. It wasn't documenting. It was like the one from India wasn't actually, this is the instructions for how surveyors doing it. It was based on an interview with surveyors. So it was a fluff piece written.
It was one example out of 5. So
yeah. So it was that one example was directed towards a non-surveyor audience. But if you want to talk about how surveyors actually do it, the documentation that I gave you would go into that a little bit. A better one, because the detail is immense, is the Transcontinental Triangulation and the American Arc of the Parallel, published in 1900.
Sorry, the what?
The Transcontinental Triangulation and the American Arc of the Parallel. In that one, they measured across the
triangulation.
Transcontinental Triangulation and the American Arc of the Parallel. Now, parallel means line of latitude again. So in there, they go into great detail for how they did it. A lot of the surveying publications don't go into detail because how you do your work is different from the results of your work. Right? I write email software. My source code is not included in the filtered emails. Right? The output of my work is not. It does not include the details of my work, and so many of the surveys don't include the details of their work. For that, you would need to go to the surveying documentation and instructional textbooks, which there's plenty of those available as well.
Thank you for that information, by the way. Can you look at my live stream again, please?
Sure.
Do you see where it's at? It's back at the...
It's spinning again. Can you just stop and restart again? Because I was off on a different screen.
is tricking everybody all the time. Maybe now?
It looks like it's trying. I'll give it a little bit longer. But that's the one from is that the one from India, right?
Not that one. Not. I have on the slide another image that I would like to show it to you, if you can see.
No, it's still not coming. Discord's a little funny sometimes.
Yeah, I ask Amy, maybe. Do you see it?
Yeah, I'm getting the spinning thing too. I think it's Discord, honestly. You could always try refreshing and see what you can do there. Yeah, if it's okay.
It's interesting because for me it's also at the very beginning when you click it, it's just spinning and then it to me.
Exactly, it does that.
Now.
Okay, thank you.
Yeah, I see you're sharing again. And I see the low-res version of it. Oh yeah, that's a different one there. But yeah, the high-res just doesn't. Maybe if you dropped, can you change the frames per second? Because it says it's 30 frames per second and you're just showing a static image. So lower quality would or lower refresh rate would be just fine.
I do that from Chrome because that's what I'm using and it doesn't give me that option.
Oh,
I think in Chrome
you're not
you
using
do that.
You're not using the Discord app?
No. That usually gives me more errors than the Chrome version. I don't know why.
Oh.
I get
I
the
know,
same
it's
issues.
interesting.
Yeah, interestingly enough, I get the same issues with it. So yeah, I understand that.
Maybe is that from a citation? Can you just drop the link
Okay,
in the
you
chat?
know what? I'm gonna drop the not the hard one. What was it? Why is it not showing just as a link? Oh, it's a PNG. Why? Why it's having a transparent background?
Transparent background PNG.
Yeah.
Okay.
But can you see
Yeah,
it
so
otherwise?
it's just SOHCAHTOA, right? Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So
we know this. I reckon you know this. So that's not my contention whatsoever. My contention is when you mentioned triangulation, because triangulation is using these functions that you could find within a triangle. Now that means that those sides you would measure in reality, by the way, are straight lines.
Okay. And?
It's not supposed to be on a curved surface whatsoever, because otherwise it wouldn't work.
Okay, show me an actual example of how surveyors do their work then.
When you mention triangulation, I'm going to show you a triangulation regarding surveying. I think I have seen that somewhere, so I'm going to find it again. easier to screenshot than make it because of the PNG. So, for example, this is a simple kind of triangulation. And as you can see, they are always using simple Euclidean triangles. Now that means that when you have like, if you would click on the image, then you will see a little bit better what's written on each side. Now, they are calling calculated distances, calculated this, calculated measured angle, blah, blah, blah. All those sides are always made up of straight lines, which means that these distances, as I mentioned before when I was talking about the maps, distances are measured as straight lines and nothing else. No curve whatsoever.
Yeah,
Because
so
then
it's a straight line.
Triangulation wouldn't work.
No, actually not at all. There's no problem at all. So these are straight lines from an elevation above the Earth to another point that is elevated above the Earth. There is no problem with these lines being straight. They aren't actual along the surface of the Earth, curving with the Earth. These are points in space above the surface of the Earth. Straight lines, no problem. What do you got?
Of the Earth. Yeah, but they are referencing the Earth itself because it says distance. And in your model, you have the distance as a curved line.
Yes, the distance across the surface is a curved line. Correct. But they're not using the triangles.
And it shouldn't work.
To do it works just fine. But,
using the triangle.
Well, go ahead. Show me. Show me the mathematical proof that would not work. Guess be your next thing.
What the Euclidean geometry is using a triangle which has straight sides. In that Euclidean geometry, you can find correlations in between the sides and the angles within a triangle, especially, by the way, a right angle triangle. You can find in any kind of triangle within Euclidean geometry. Now, in spherical and hyperbolical, you cannot.
Okay, we'll show the mathematical proof of that then.
Mathematical proof that you have to use straight.
You have claimed, yeah, you have claimed a whole bunch of things about spherical geometry that mathematicians disagree with. So it's on you to provide the mathematical proof that you can't do triangles on the surface of a sphere, I suppose. Go ahead. Are you saying that you cannot do triangles on the surface of a sphere, that spherical triangles do not exist? Is that your claim?
Did I ever claim anything like that?
Okay, so well, I mean, because you're saying that you can't do triangulation on the surface of a sphere. That's your claim, right?
My claim is twofold, that yeah, that kind of triangulation would not use any kind of sine and cosine functions that you would find in Euclidean, because it's not Euclidean, it's that easy.
So you don't actually know a whole lot about spherical geometry, do you?
That's what they are using, mate. When they are having one side for the triangle, meaning one distance, and a certain angle which they get from, let's say, a theodolite, then they are going on with the Euclidean geometry from that. Euclidean, not anything else.
Well, that would be where you're wrong, because they're using they use spherical trigonometry at times. It depends what their purpose is and their margin of error that they need.
They are not using sine, cosine, and other functions that are signs are within Euclidean geometry.
Well, let me just. I guess it's there. Okay.
Because again, if they are not using that, then why didn't they use, let's say, in this image that I posted, but I can show you others, of course, anytime. Why don't they use curved lines at all? How is that a representation of anything then?
Here you go. Well, I mean, your diagram is just a diagram. It's not actually, what they use in their coursework. When somebody teaches a course on these things, it's not, they don't use that diagram and that's the end of the course. They actually do a little bit more than that. But here is a from Wolfram Alpha or just Wolfram, not Alpha, on spherical trigonometry. And there are functions that use sine and cosine in spherical trigonometry. You see that? There's angle A, angle B, angle C, and line A, line B, line C, and the radius R. There are relationships that you can do to solve triangles that are spherical triangles. Spherical triangles exist. Spherical trigonometry exists. You can use trigonometric functions to do your math in spherical trigonometry. So I don't know why it seems that you think that this doesn't exist, maybe, but maybe I'm putting words in your mouth. But you can see here
I said they don't use it. I didn't say it doesn't exist. I said they don't use that.
Well, that would be wrong then, because like I said in the book that I referenced, the principle, the triangulation of the American arc of the parallel, they do use spherical trigonometry. So that's easy to show is wrong.
Okay, I just posted something in live stream too, again. And that's the triangulation in Nebraska that was actually done.
So they went the wrong. I heard.
When was it done? I'm trying to find a date. 1899, by the way.
All right. So you did you put something? Oh, there.
See in this kind of diagram that was, drawn up by surveyors.
Okay.
Simple triangles. Nothing else.
Does this show the math that they used, or is it just a couple diagrams again? You think that diagrams is it, huh?
Oh, this is like a simple orthographical view of the land and then putting on some actual triangulation, because this is how it's done.
Okay. And do you have any of the results of this particular survey?
By the way.
Do you have any results of this particular survey?
I need to know that when I'm only talking about if they are using triangles or not.
Yeah. And so how do you know whether or not these triangles are spherical triangles or planar triangles?
Mate, because that's how it's drawn up. Like it's that easy.
Because
you can see
because of the diagram again. You think the diagram is all that matters. So forget what they actually did. Forget the actual work that they did, and let's just look at the pictures. That's what you want?
It's called a triangulation map. This one is actually not just a diagram. This is called a triangulation map.
Yeah.
That's not just arbitrary drawing that you make at home in Paint.
Yeah. It's a triangulation map. Yes.
What they use to determine certain distances.
Yeah, and surveyors, when doing these large triangulations, use spherical trigonometry. Like I said, in the book that I referenced, goes over some of these details. So do you have the Shelton base net citation? I would love to see that. Do you have that?
You want me to present something that is a written text, and signed by blood, that they are only using simple Euclidean geometry?
No, I want the citation, because I'm pretty sure the citation will talk about the measured triangles and the actual numbers of the measured triangles.
The actual numbers are somewhere in there. I'm not sure what they are referencing, by the way, but they are there. I'm not a surveyor. I cannot read a map like this just off the top of my head. I would have to look it up, of course. But this is how the map they are using for triangulation looks like. And all I see there are simple triangles.
Yeah, and how would, if they were going to draw on this two-dimensional surface a spherical triangle, how would they draw it?
Spherical, the surface of a sphere cannot be developed. That means I
Absolutely. So they
simply
could
go-
not actually draw a three-dimensional spherical triangle on a two-dimensional surface. They could only use a representation of it. So you cannot look at the triangles
Exactly my
that they
point.
drew and determine whether or not these triangles are spherical triangles or planar triangles. What you need to do is look at the actual measurements of them to see if they sum to more than 180 degrees. Did you do that?
What I do know is that if you are using simple triangles, but you have the supposition that the surface is actually curving, then you shouldn't come up with the right calculation for any distance, especially over long distance. You cannot.
Absolutely, and they always use, for long distances, spherical trigonometry.
No, this is what they use, and this is not spherical geometry in any way.
Oh, well then show the measurements. Let's see some of these
Measurements of what?
These triangles to see if they sum to more than 180 degrees or not. What do you think?
Wait a second. Are you trying to claim that if we would actually measure any triangle within that map drawn up, we would come up with a triangle that is not having 180 for its inner angles as a sum?
That's my question to you. Did you look at them before you cited this?
Wait, if you are connecting 3 points in a series
on a plane,
give you a triangle.
Yep, on a plane, and they summed on a plane. They summed 180 degrees. On the surface of a sphere, they always sum to more than 180 degrees. That's how spherical triangles work in spherical trigonometry.
This is not a spherical triangle that you are looking at. This is a map. That's what I'm trying to tell you.
That is definitely what is in contention, though. Because you didn't actually look at the details. But tell you what, let me show you, because I don't know the details of this one, but I do know the details of the one that I previously cited, and I'm sharing that right now if you want to have a look at it. These are the actual triangles. Do you see that?
This is the map
are you seeing
that
it? It's
the surveyors actually use.
Supposing
that they use something else also. That's not good.
Do you see what I'm sharing?
Just to let you guys know, there might be a lag or something. Oops, can you hear me? I'm sorry to interrupt, guys, but I just want to let you know there might be a little bit of a lag. We're getting some over talking on both sides, okay? Just wanted to check in and let you know. Thank you.
So, what's up? Are you seeing what I'm sending here?
Sure. Yeah.
Okay. So this is a similar diagram to what you showed, right? A triangulation net. Right. You see that? And here are the actual measurements. You see here, Ibapa, Pilot Peak, Ogden Peak. We can go back to this one here, and we can find all of those points on this. This particular one, right, or other ones in the book. I think this may not be
I get it, yeah.
the same one.
I get it.
So,
I get what you're trying to show.
All of the triangulation nets are diagrammed in that book. Again, this is the triangulation of the American arc of the parallel. And then these are the measurements of the triangles. These are the angles of the triangles that they measured using theodolites. It's 53 degrees, 38 arc minutes, 37.117 arc seconds. Pilot Peak is 91, 59. Right? They sum.
I'm adding up right now, yeah.
Yep. They sum to 62 arc seconds more than 180 degrees. That's what that 62.160 is at the bottom. You see that?
Oh, okay. Then I don't even need to. Okay.
Yeah. So that particular triangle sums to more than 180 degrees.
How much is that in degrees?
Well,
From the top of my head.
An arc second is 1/3600th. An arc minute is 1/60th. So that's 62 arc seconds, which is just a tiny bit more than 1 arc minute. So let's just call it 1 arc minute. That's 1/60th of a degree more than 180 degrees. But you can see they carried 3 digits of precision.
7.
Yeah, so but you can see they carried 3 digits of precision in after their arc second measurement. So this particular margin of error is extremely small. It's much, much less than 1 arc second. So this particular measurement is almost 2 orders of magnitude larger than the margin of error. So it's a significant
where is the margin measurement of error in this image?
Yeah, you can see that they have 3 digits of precision after the decimal point for arc seconds. Do you see that? So that 37.117, that is arc seconds. Right? So their margin of error is going to be somewhere within that final digit.
Supposedly, yeah.
Yeah.
They didn't calculate something over and then just, claim that it must be there. It must be there. But again, that arc second is converting to 0.01 degrees. Now, will you imagine in real life that you could be off by that much when you are measuring 3 angles, one after another?
Well, like I said,
anytime I can. Yeah.
Yeah, like I said, they actually carry 3 digits of precision after the decimal point for arc seconds. So their measurement error
87. I just see that 87 they had a precision of that small accuracy. Wow.
Yes.
Okay.
They were using 20-inch long telescopes. Right? Extremely precise measurements here. So the point is, I mean, if you want to just declare, hand wave that they couldn't possibly do it, then you go right ahead. But denialism isn't evidence; it's just denialism. So you feel free to look through this particular documentation. It's quite thorough. It's 900 pages. The thing is, every one of these, right? So if they're off on one, well, then the next one, and the next one, and the next one, and the next, they're over 180 degrees on every one of these triangles. You see that?
By 0.012 degrees.
Yeah, and
yes, I do see that. Yeah.
And their instruments are able to measure significantly more precise than that. So all of these are more than 180 degrees, showing that these are not planar triangles. They are. It is not possible on a plane for a triangle to have more than 180 degrees. These do have more than 180 degrees. Therefore, they are not planar triangles.
Again, I still have a contention to that because it's 1887 and we are talking about a very, very small amount of margin of error.
But do you have any evidence?
Way within the human error.
Do you have any evidence that their margin of error is
even
is
the
wrong?
Human error?
Do you have any evidence of that other than
the human error?
It sounds like all you have is denialism. You don't have any evidence for this.
I might have for next time if we would ever have, but from the top of my head, I cannot show it to you right now.
Well, I have sent this particular document to many flat earthers. They always say they're going to have a look, and they come back. Well, they never come back. So
that's the good story.
Hey, maybe you'll be the first. Again, that's on my website. You can download it from there, or there's a link to the original source. My website, mc2.net/r. It's the 5th measurement of the radius of the Earth listed on that page. All right. But I do appreciate that Chadwick one that you sent. I will have a look at that and see if I can get the source data, because it looks like the same types of triangulation maps.
Okay. I think it's been 2 hours, and I really do think, by the way, that the audience is getting more and more bored.
Yeah, I understand. I think it's a good time. I'll even unmute Crux so he can so I can hear him next time.
Okay.
So I just wanted to say, sorry, before Amy jumps in, I just wanted to say that thank you, Toon, for being civil about all of this.
Yeah, thank you. And we get hot, and I think if we can come out of it smiling, I think it's a good idea.
Absolutely. And I do want to thank you both for coming and doing such a great job and staying so calm for the whole 2 hours. That's amazing. So thank you both for that. I also want to thank everybody in the chat for commenting and having good, good pictures coming up and links and everything. And I want to thank everyone's patience in the in the stream itself in the VC. And I want to thank our gracious hosts, too, for having us on and being so wonderful about it. This is a great platform, so thank you for that, too. Thank you.
And I would like to thank you, Amy, also for moderating the debate, which didn't take much today, at least.
No, it didn't. And thank you very much. I appreciate it. You both did a great job. Both of you did. So thank you for that. And I've learned something from both of you, so that's awesome. Thank you.
Yeah, thanks a lot. Thanks, What's Up, and Amy, and Bev, if you're still here, thank you for facilitating this.
Yes, absolutely.
It's not
Thank
me.
you.
It's not me.
Thank you
It's,
for hosting
Geo.
us.
A Geo server.
I don't hear him
Everybody
talking.
have a good
I don't
night.
know if he's.
Thank you. You too.
Yeah. All right. We'll see you later.
Yeah, well done. Is that it? Are we over? Are we done? Are we taking questions from the audience?
I'll gladly stick around for that.
That's our time, anytime. Yeah.
Very good. Open the floor then.
I have a question.
By the way,
Mr.
yeah, Emma is
McToon.
very right. I would just one more sentence. Sorry, everybody who was in the voice chat, thank you very much for your patience and not cutting in, because that's also kind of a surprise to me. So thank you everybody for that.
Yeah, it was pretty good.
Yeah, sorry for jumping in. I didn't realize that it was a closed debate.
No problem.
McToon, can I ask you a question?
Sure.
This is SC Montreal, by the way.
I think I recognize your voice.
Great, thanks. I was always meaning to ask you about the twin boat paradox. If you ever had a look at it, if you care to comment.
The twin boat?
Yes, the twin boat paradox. If you care, I could explain it to you in like 30 seconds.
Sure. I don't know if I've heard of it.
Okay, here it goes. We have two identical boats. We're on a river, very calm day. The boats are about 5 miles apart. And you have two people stood on the bow looking at each other. How does the water appear to them?
If they're low enough, then the bottom of the other boat should be obstructed. And at 5 miles away, it might not be if you're standing on the bow. But
at 5 miles, you can pretty much see each other. It's a clear day.
Yeah, I agree.
But I'm talking about the water now. How would you envision the water?
What do you mean? How do you envision it?
Like, how would the water look? Would it be like Is there like a curve, a drop, a hump?
Over
what is
over 5 miles without
Would it ramp up to the middle of your vision?
Well, yeah, due to perspective, it all ramps up.
So you would say there's a hump between the two boats, like a slight curve, let's say, like a little pot belly or something.
At 5 miles and from the bow of a ship, you would not be able to differentiate that hump.
So the water would appear,
but there would be a hump.
Straight? How?
You would not be able to differentiate either way. It's not long enough, and there isn't enough curve to see whether, you know, and I'll leave it open, whether there is curve or not. You could not tell over that short of a distance.
How much should
How
there
much
be
of a
on your
distance
model?
would you say
5
like
miles.
you would need?
Well, you can. It depends on the height of the observer and how far away the distant object is.
Okay, correct me if I'm wrong though. In your model, doesn't the water start to curve immediately at the bow of the ship or any other surface for that matter that's in the water or anywhere else?
Yes.
So how do you square that? How do you square that in your head?
If you have a mirror, and that mirror is say 3 feet long, and it has 1 degree of curve in the surface of that mirror, do you think you could tell that 1 degree of curve?
But that's not the issue. If in your model,
let me go through. Can I go through this analogy here?
Of course, yes.
Okay. Could you see with your own eyes the curve of 1 degree over 3 feet?
I'm guessing now, probably not.
Okay. So it takes 69 miles over the surface of water to get 1 degree of curve. So the same amount of curve, 1 degree over 69 miles versus 3 feet, and you don't think you could see 3 feet, see 1 degree in 3 feet. So we definitely would not expect with our eyes to be able to see 1 degree of curve over 70 miles, right?
Well, I've went to the beach and I don't see a curve, but according to your model, we should start to see curve immediately. And
I just made it clear. No, hold on. I don't want the straw man here. I just made it clear. I do not expect that you would see on the surface of water in 69 miles, you would not see 1 degree of curve because your eyes cannot see 1 degree of curve in 3 feet. So neither of those instances should you be able to see with your own eyes the curve.
Hey,
I understand what you say, what you claim. Okay. That doesn't matter what you claim and say. In your model, an observer standing on the beach starts to see the boat disappear 3 miles bottom down. Doesn't matter what you think. I'm telling you your model. So would you care to maybe like rephrase your answer?
The difference between obstruction and just seeing on the surface of water is different. So yes, you will see things being obstructed bottom up with increasing distance. But lacking that, just looking at the water and nothing else, you would not expect with your eyes to be able to differentiate 1 degree over 69 miles. No way.
So then you disagree with all the old observers and Tyson and all these guys that say when you stand at the beach, you start to see the bow disappear. That's physical obstruction at 3 miles. You disagree with that?
Different topic. So let me restate my position, okay? Over the surface of water, when you don't have anything else that you're looking at other than just the water, you would not, with your own eyes, be able to differentiate the curve. But if there is something, a distant object that you're looking at, it will be obstructed bottom up with increasing distance.
So you just said 2 things now. Before you said that the boats that are 5 miles apart see absolutely nothing. Now you're claiming something different.
Well, let me restate the boat thing again. From one boat to the other, the surface of the water, your eyes cannot differentiate any curve. But if that other boat is far enough away, it will be obstructed bottom up. But the water between you and the boat, your eye will not be able to see the curve in that.
Again, that goes against your model, because at 3 miles, there should have been obstruction there.
Not from
You see
the,
what I'm
not
saying? You
from
see
the
where
bow,
the
not
paradox
from the
is starting
bow,
to come in clear there?
not from the bow of a ship. You're too high. You're 5 mile away ship. When you're standing on the bow, there's nothing that should be obstructing it.
It's a low ship. You're 6 foot off the water. It's a very low ship.
Toon, I'm gonna post a picture. It's it's way more simpler than you think it is. It's essentially asking about that. If two observers are looking at each other, what are they seeing as far as possible obstruction?
Yeah. Okay.
So, Toon, you realize that you said 2 things there, right? I want to make that clear.
No, he didn't. Essie, you're just being obtuse about it. He didn't say 2 things there.
Wow, was he coming in getting a
I
save?
think Matt Toon can answer for himself.
So, to be very, very clear, again, if you're looking at just the surface of the water, your eye isn't good enough to differentiate curve or not curve. If you're looking at a distant object, it will be obstructed bottom up with increasing distance.
Right, but that doesn't say anything because, again, the 2 boats are 5 miles apart and you're saying that the water is perfectly straight. But then on the other example, you agree that at 3 miles...
I did not say the water's perfect.
If you don't mind, that same lag might be going on. Please don't cut him off mid-sentence.
I'm good. I'm good. Go ahead. Go ahead, Toon. Go ahead.
You keep misrepresenting my position. So I don't need to state it anymore.
If you want to clarify, I mean, I heard... Sorry, go ahead.
I keep clarifying it, and you keep restating it wrongly. So I can't restate it any more correctly. Please stop restating it wrongly.
So what is your obstruction that's when you're observing a ship, as you called it, a distant object, and it's obstructed bottom up, what is that obstruction in your mind? Like
the curving surface of the water.
Okay, fair enough. So on a curve, right, on a curved surface, that would definitely happen. I agree with you. Even on a curved surface, what else could obstruct it, especially as you're looking long distance with your eyes over, let's say, water?
That would be.
And what's the height of the observer?
On the water.
Any height you pick.
Keep going out. Yeah.
Okay, so let's put them at 20 feet high.
The line defined or the plane defined as horizontal.
So what other than the curve of the earth could obstruct
from your feet
if it's just water?
Yes, if you're viewing it with your eyeballs over water.
Yes. Yeah. So the waves that are at the peak of the curve would be the most obvious things.
Refraction. No. Let him answer. He's on his way. That's one. Okay. We're still on a curve, right? I'll give you that. Fine. So waves. What else? I mean, you're a smart guy. You can.
What else would cause obstruction?
Over
water?
Yeah, let me tell you.
Another boat.
Hey guys,
real quick.
we're very rarely getting
has a list of about 100
Rob,
reasons.
why are you interrupting McToon's answer? I'm very confused. We very rarely get him here. McToon, I'm sorry about that. Go ahead. So
we're not going to get one. Sorry, Dave.
Yeah, it's especially this way. So McToon, on a curve with obstructed physical water, waves going higher than that, eye level or at your horizon would obstruct. What else?
Another boat? An island?
Okay.
Over a curved surface. What else? Those are there's obviously any number of things that we could imagine.
Can I answer? No, let's not imagine. No, let's give him a fair chance. Let's not imagine. We know we're observing over water through the air at long distance to an object that could be obstructed by many different things. You've mentioned several. Do you have any more that might come to mind?
No.
Okay, so the medium itself, you don't think that would affect how we're viewing things through the medium?
Oh, the medium certainly can affect it, but it generally won't cause obstruction. It generally will reduce obstruction.
Why do you put generally there? Just sometimes does it?
Yeah, there are cases where you can have inverted indexes of refraction gradients.
Would that happen a lot over? Oh, I'm sorry. Go ahead.
Yeah, and over conditions that you generally can see because there's other artifacts that you can see in your view that happen, like miraging and things like that. So that's why I said let's do it at 20 feet high or even higher, because then you get out of the area where lots of miraging happens.
Yeah, that seems to be a claim, but not just miraging, right? We get other types of refraction that can obstruct or distort, is what I like to say. You're not getting that light. However, it's not getting back to the viewer due to many different factors, right? I mean, you would have to agree with that.
Yeah, and it generally comes down to the index of refraction gradient. Right?
Okay,
and
so let me just summarize. You think it's Earth curve, more or less. You've mentioned other factors, and that refraction, for a lack of better terms, but the atmosphere, the way you're viewing things through the medium, could contribute to the bottom-up obstruction, McToon?
In extreme circumstances and exceptional corner cases, it does happen, yes.
Would these extreme circumstances usually happen long distance over, let's say, the medium of water? Like if water was below, causing these effects? You think it happens more over water or land?
The largest amount of refraction or index of refraction gradient, like messes, is in the afternoon and early evening of days where there was sunny and no clouds. So those are where you get the most dramatic index of refraction gradient messes.
You think that's more because of temperature change or variation, or angle of the light source, or both?
Well, it's both. Yeah, the Snell's law is a lot about the angle of light.
I agree with you, man. I'm on this with you.
And temperature is the at low atmosphere is the primary index of refraction variant.
Okay, so you've been a good sport over the sphere, right? So over a flat plane with similar conditions, or let's just say worse, right? Could bottom-up obstruction happen due to these conditions optically?
You can, but it's a dramatic.
Nah, that's good enough. You can stop there.
No, I get to finish my statement. Okay.
Oh, okay.
It would require a dramatic index of refraction gradient inversion to do that.
But that's based
and
on
like I said, hold on, I wasn't done.
Okay, fair enough. Go ahead.
I wasn't done.
Go ahead.
And the dramatic and it's an unstable gradient because it requires the temperatures to be inverted. It requires cold temperatures to be high and high temperatures to be low, which convection will reverse them quickly, left undisturbed.
Huh. Yeah, that's.
Can I have one final question?
Go ahead, man. I think I made my point.
Yeah, you did, Rick. Yeah. McToon, if I may, can I have one final question?
Sure.
On the twin boat paradox. I just want to get clarity. According to what you think, when does the water, because you said there's a curve eventually, fine. When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah.
Okay. Thank you. You've been a great sport. We'll leave it at that.
Can I just come in here now? I'm going to post a little, it's only a 23-second clip. This is one, and then there's another one, right? Do you want to have a listen to that? Because you seem to contradict it.
Just a second. Okay.
So the horizontal would be going out from your feet,
Listening.
and that would be the horizon on the water.
That would
level
be
would keep going out. Yeah.
That would be horizontal. That would be the line defined, or the plane defined as horizontal.
Yes. So from the water level, from your feet, would go out towards the horizon horizontally.
Yes.
Okay. And I'll just get you another one that just to have
That was
a
okay.
little list.
That was great, Bev.
So, Bev, what's your question?
Wait a minute. I'll get one more. There's one more clip. This one. Okay.
Why he's getting it. Thanks, Mattoon. Appreciate it.
Mm-hmm.
Hey, you're welcome.
That other one there, that I've just posted that one.
All right, listening. Well, that's...
I'm not arguing the horizontal.
Okay, so what's your
plane
question,
defined by
Bev?
the water level. I'm
Well,
perfectly fine with that.
You've said in both of those clips that the water level is a horizontal plane.
Yeah.
Okay. Now, did you just say to SE that it was dropping from your feet?
Yeah, so here's what it is, Bev. I'll explain again. And I think I did it before when I talked to you before, but it defines a horizontal plane tangent to a single point on the surface of the curve.
Mm-hmm. To the horizon. From your feet to the horizon.
No. A horizontal plane
That's what you said in the
tangent.
first clip.
Let me just clarify.
Mm-hmm.
It defines a horizontal plane tangent to a point on the surface of a curve. And if anybody's ever done calculus, you get to explore these concepts a lot in the introductory calculus things.
So can I go over it again? From your feet to the horizon when you are stood at the water's edge, which is what we were talking about, that is horizontal, but you claim that is a tangent.
No.
Okay,
From your
you've gone
feet,
off a tangent. Right, okay.
From your feet to the horizon, you can define a plane. You can define a plane anywhere you want. But the plane from your feet to the horizon is not horizontal at your point. It diverges from horizontal at your point.
But you did say it's a horizontal plane in that clip, right?
Well, maybe I misspoke. Maybe you misunderstood.
And that other one where you said the horizontal plane of the water level is not in contention.
Like I said, and I'll say it again, and please don't misquote me again or misunderstand me.
It's like you did it.
You can define a horizontal plane tangent to one single point on the surface of a sphere.
I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
So when the water level has 2 points, do you mean the plane from one point to another, like on the water level?
The plane that is then defined by that. Well, that with 2 points of a water level, you only get a line. You don't get a plane. Say so. If you had 3, you could. But we can extend it once we talk about.
You can move the water level ends wherever you want, and it would be a horizontal plane. That's why we call it a horizontal plane.
Yeah. So you have two parts of a water level. The point that is
hang on. It only needs 2 points.
Rob, please.
The point that is equidistant from both sides of the water level, that point there, so right in the middle, the horizontal plane is right at that point.
So, but it would all be horizontal. That from one water level to the other end, that entire line with the bit in the middle that's horizontal as well. Like all of it's horizontal, isn't it?
Yeah, and that will diverge from the line to the horizon.
But not from the line to the water level.
Yeah, the line between the 2 water levels is a line tangent to the curve at the point at the midsection point.
So the water level does establish a plane.
It does establish a plane, and that plane diverges from the surface of the earth.
The plane that the water level makes diverges from the surface of the earth. Can I just get a clarification?
Yes. Yep, the 2 points of the water level, you draw a line with that, and you can extend it to a plane. That line will diverge from the surface of the earth with increasing distance.
Make sure again, the water level, the tool, establishes a
Yes.
plane, and you say that plane diverges from the surface.
That's right.
Thank you.
Okay.
What about for now?
That must diverge from the surface. Must do.
All right. There was one other guy asking questions. I think I could, if you wanted to, but then I need to get back to some other stuff.
Yeah, I bet you do.
But he's asking me anything. What the fuck? Sorry.
So who was that had another question?
Well, can I ask what's up then? What do you think about the idea that a water level establishes a horizontal plane that diverges from the surface of the Earth? What do you reckon about that? What's up?
If it's, what is diverging from what again?
The water level establishes a horizontal plane, and somehow that horizontal plane diverges from something, is what Toon said. I don't know. I'm still trying to wrap it around.
I don't get the question, to be honest with you, because if it's a horizontal plane, then it's a horizontal plane throughout, no matter
he
how
said
far you
he said two. He said 2 points of the water level.
Oh, here we go.
Establish a horizontal plane.
Yep.
Yeah, high school
not-
graduates
That's
agree
what
with
we've
him.
been saying, RC, yes.
Could have
2
been
points of the
tangent
water
at the
level
midpoint.
do make a horizontal plane, yes.
Tangent at the
Literally,
mid.
a horizontal plane is infinite, by the way. Like literally, that's how it's presented. Frame of reference. Therefore, it's supposed to be infinite. A coordinate system, for example, doesn't have an end, does it? So that's my answer to that. If it's satisfactory enough, we can move on.
Yeah, my job is done.
I've got a quick question for McGoon. Is he still here? So, MC, are you still here? Toon?
Yeah.
Yeah. So, in your last example, which deviates from which? Does the surface deviate, the sphere deviate from the water level, which is forming a horizontal plane, or does the horizontal plane deviate from your curved surface?
They deviate from each other.
So how does the water surface deviate from your sphere surface?
The water doesn't deviate from the sphere surface.
But you just said the water forms a horizontal plane, which is the tangent.
I'll say it again. I'll say it. This is high school geometry here. So, and I'll do it again. This really doesn't have. This really doesn't have
tone.
Okay, interrupt me again, and I'm gonna leave. Okay.
I don't care. Just stop condescending.
Do care.
So get on with
he's
it.
looking for a way. He's looking for a way out. Don't trigger him,
He's
you'll
gone.
leave.
He's gone.
Back just. Oh, good.
He's gone. That's all it took.
I think that question pinched him.
McToon, if I may, can I have one final question?
Sure.
On the twin boat paradox. I just want to get clarity. According to what you think, when does the water, because you said there's a curve eventually, fine. When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah.
Okay. Thank you. You've been a great sport. We'll leave it at that.
Can I just come in here now? I'm going to post a little, it's only a 23-second clip. This is one, and then there's another one, right? Do you want to have a listen to that? Because you seem to contradict it.
Just a second. Okay.
So the horizontal would be going out from your feet, and that would be the horizon on the water.
That would
level
be
would keep going out. Yeah.
That would be horizontal. That would be the line defined, or the plane defined as horizontal.
Yes. So from the water level from your feet would go out towards the horizon horizontally.
Yes.
Okay. And I'll just get you another one that just to have a
okay.
little list.
That was great, Bev.
So Bev, what's your question?
Wait a minute, I'll get one more. There's one more clip. This one. Okay.
While he's getting it, thanks, Mattoon. Appreciate it.
Mm-hmm.
Hey, you're welcome.
That other one there that I've just posted. That
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that. Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that. I'm not arguing the horizontal
Okay, so what's your
plane
question,
by the
Bev?
water level. I'm
Well,
perfectly fine with that.
You've said in both of those clips that the water level is a horizontal plane.
Yeah.
Okay. Now, did you just say to SE that it was dropping from your feet?
Yeah, so here's what it is, Bev. I'll explain again. And I think I did it before when I talked to you before, but it defines a horizontal plane tangent to a single point on the surface of the curve.
When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah.
Mm-hmm. To the horizon. From your feet to the horizon.
No. A horizontal plane
That's what you said in the
tangent.
first clip.
Let me just clarify.
Mm-hmm.
It defines a horizontal plane tangent to a point on the surface of a curve.
So from the water level from your feet would go out towards the horizon horizontally.
Yes. And if anybody has ever done calculus, you get to explore these concepts a lot in the introductory calculus things.
So from the water level from your feet would go out towards the horizon horizontally.
Yes.
So can I go over it again? From your feet to the horizon when you are stood at the water's edge, which is what we were talking about. That is horizontal, but you claim that is a tangent.
No.
Okay,
from your
gone
feet.
off it.
When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah.
Tangent. Right, okay.
From your feet to the horizon, you can define a plane. You can define a plane anywhere you want. But the plane from your feet to the horizon.
So from the water level from your feet would go out towards the horizon horizontally.
Yes. Is not horizontal at your point. It diverges from horizontal at your point.
When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah, point.
But you did say it's a horizontal plane in that clip, right?
Well, maybe I misspoke. Maybe you misunderstood.
And that other one where you said that the horizontal plane of the water level is not in contention.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
Like I said, and I'll say it again, and please don't misquote me again or misunderstand me.
It's like you did it.
You can define a horizontal plane tangent to one single point on the surface of a sphere.
When does that curve start? I want to know. From the bow of the boat. It's touching the water now. When does the curve start?
I can make it more clear. It's always curved. It never starts. It's always there.
So immediately, right?
Yeah.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
So when the water level has 2 points, do you mean the plane from one point to another, like on the water level?
The plane that is then defined by that.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
Well, with 2 points of a water level, you only get a line. You don't get a plane. So if you had 3, you could. But we can extend it once we talk about.
You can move the water level ends wherever you want, and it would be a horizontal plane. That's why we call it a horizontal plane.
Yeah. So you have two parts of a water level. The point that is
hang on, it only needs 2 points.
Rob, please.
The point that is equidistant from both sides of the water level, that point there, so right in the middle, the horizontal plane is right at that point.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
So, but it would all be horizontal. That from one water level to the other end, that entire line with the bit in the middle that's horizontal as well. Like all of it's horizontal, isn't it? So from the water level, from your feet, would go out towards the horizon horizontally.
Yes, and that will diverge from the line to the horizon.
But not from the line to the water level.
Yeah, the line between the two water levels.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
Yeah.
Is a line tangent to the curve at the point, at the midsection point.
So the water level does establish a plane.
It does establish a plane.
So from the water level, from your feet, would go out towards the horizon horizontally.
Yes. And that plane diverges from the surface of the earth.
The plane that the water level makes diverges from the surface of the earth. Can I just get a clarification?
Yes. Yep. The 2 points of the water level.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
You draw a line with that, and you can extend it to a plane. That line will diverge from the surface of the earth with increasing distance.
Make sure again. The water level, the tool, establishes a plane, and you say that plane diverges from the surface.
That's right.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
Thank you.
Okay.
What about for now?
That must diverge from the surface. Must do.
All right. There was one other guy asking questions. I think I could, if you wanted to, but then I need to get back to some other stuff.
Yeah, I bet you do.
But he's asking me anything. What the fuck? Sorry.
So who was that had another question?
Well, can I ask what's up then? What do you think about the idea that a water level establishes a horizontal plane that diverges from the surface of the earth? What do you reckon about that? What's up?
If it's, what is diverging from what again?
The water level establishes a horizontal plane, and somehow that horizontal plane diverges from something, is what Toon said. I don't know. I'm still trying to wrap it around.
I don't get the question, to be honest with you, because if it's a horizontal plane, then it's a horizontal plane throughout. No matter
he
how
said
far you
he said 2 points of the water level.
Oh, here we go.
Establish a horizontal plane.
Yeah.
Yeah, high school graduates
That's
agree
what
with
we've
him.
been saying, RC, yes.
2
points of the water level do.
Well, I'm not arguing the horizontal plane defined by the water level. I'm perfectly fine with that.
Make a horizontal plane, yes.
The tangent at the
Literally,
mid.
a horizontal plane is infinite, by the way. Like literally, that's how it's presented. Frame of reference. Therefore, it's supposed to be infinite. A coordinate system, for example, doesn't have an end, does it? So that's my answer to that. If it's satisfactory enough, we can move on.
Yeah, my job is done.
I've got a quick question for McGoon. Is he still here? So, MC, you still here? Toon?
Yeah.
Yeah. So, in your last example, which deviates from which? Does the surface deviate, the sphere deviate from the water level, which is forming a horizontal plane, or does the horizontal plane deviate from your curved surface?
They deviate from each other.
So how does the water surface deviate from your sphere surface?
The water doesn't deviate from the sphere surface.
Right, okay.
From your feet to the horizon, you can define a plane. You can define a plane anywhere you want. But the plane from your feet to the horizon is not horizontal at your point. It diverges from horizontal at your point.
So you just said that the water forms a horizontal plane, which is the tangent.
I'll say it again. I'll say it. This is high school geometry here. So, and I'll do it again. This really doesn't have. This really doesn't have.
Tone.
Okay, interrupt me again, and I'm gonna leave. Okay.
I don't care. Just stop condescending.
Do care.
So get on with
he's
it.
looking for a way. He's looking for a way out. Don't trigger him,
He's gone. He's gone.
Back just. Oh, good.
He's gone. That's all it took.
I think that question pinched him.
I think at that moment was
Hang
the
on,
moment
I
he
leave for
realised.
5 seconds and he's gone.
DP.
Yeah, sure.
DP.
Sorry, Emma.
It was at this moment that he knew he fucked up.
What did you say to him?
Yeah.
No, Bev, you just keep asking the same damn question over and over.
No,
Mike,
said
shut up. It was
he
me
said
that asked the
the
question.
horizontal plane diverged from the surface. Now, every one of you guys has got to admit that's not right on your model.
Yes, it is.
The correct answer is there is no such thing as a horizontal plane on our model. That isn't it?
That's
Like the water canal.
That's not true.
Left lane, do you know what a canal is?
You don't have horizontal planes on your model. They don't exist.
It
Not along the
perfectly
surface, no.
A horizontal plane tangential to any point. What's wrong with that, Bev?
But McGoon was saying that horizontal plane is formed of water, by water.
No, he wasn't.
No, but
Yes,
he
he
said by 2
was.
points on the
Bev
water
got-
or as a
Bev
tangent
got
to the
him to
plane.
reiterate that 3, 4, 5 times.
And I'll get you the clip as well that he was doing.
I'm pretty sure it's recorded.
I'll put it up so
Yeah,
you
one
can
of
hear
them
it.
misunderstands.
McGoon's
I
has
didn't-
just fucked up royally, and you all know it.
No, I don't. I didn't understand him to say that at all.
Go on, have a listen to that. I'm just going to put it back up again in live stream 2. McToon, horizontal plane. I even get him to confirm it in that, and he confirmed that as being
Yes,
true.
he said 2 points or a
Thanks,
tangent
Bev.
point, Bev. Like you're just conflating 2 different things and then pissing on yourself.
Look at the picture at 2:33 posted by I'll Show You My Curve. That was about 3 minutes ago. Sorry, 4 minutes ago.
Yeah, but you're all missing
Bev, I
the
just
fact.
listened.
Oi, shut up! You're all missing the fact that he said that this horizontal plane is formed by water.
Yep.
You all seem to
Said
be
by
skirting
2
around this
points.
fact.
Hey, hold up. He said 2 points with a water level. He said you can take those 2 points and you can create a plane with it, or you can take a tangential point to the surface of the Earth and create a plane with that one if you'd like.
You can take
You asked
any
for
2
2 different
points
examples, and you
anywhere.
got 2 different answers
That's what the tilde
that
is.
are both congruent with each other. That when you have a curved surface, if you have 2 points, you can create a
It's
freaking
okay,
horizontal plane.
don't
with it.
get triggered. It's McToon that said it.
Nobody's triggered.
Don't, you
You're
sound
just
very
confused.
triggered. Unfortunately.
I sat here and listened to the whole thing, Bev, and you're trying to conflate the 2 answers
You just
as
have
if they're
to listen to
conflicting.
what
They're not.
McToon said.
It was very clear.
Did RC bitch about tone, or was that your side? Was that your side
Didn't say
that
anything
triggered?
about
it?
it.
Who?
I'm
All
telling you,
seems to be
conflating
defending
different-
what McToon
No,
said.
no one said anything about tone. I didn't say anything. Anyway, I'm talking about the fact that Bev is taking two different answers with two different questions, conflating them, and said that he was wrong about something. He wasn't. I listened very closely.
He was wrong. He said that the water forms a horizontal plane which you can't
No, he
have.
said 2
You
points
can never
that you can measure with a lava.
arguing
No, he
the
said 2
horizontal
points that you
plane
can measure
defined
with
by
a
the
water
water
level
level. I'm
can
perfectly
create
fine
a
with that.
horizontal plane. That the surface
Yeah,
of the Earth will
that's it.
diverge
There
from
you
that
go.
plane. No. There are
There you
two
go.
planes. Bev asked him
How
specifically
can
about. Hey, stop talking.
how can
Bev
the
talked about.
surface of the water create a
Finish the
horizontal
sentence.
plane
Why is
that
everybody
then
talking over me?
diverges from the surface of your
Hey,
sphere?
stop being triggered. He asked about
I'm
2
not being
points.
triggered.
Bev asked about 2 points.
Oh, see, I'm
And
not
Mc,
triggered. It takes
McToon
more than
answered on
you
2
to
points.
trigger me. Believe me.
All right, well then stop talking over me.
All
So
right,
Bev asked
calm
about
down
2
there.
points, and he confirmed with 2 points. And he said that the surface of the Earth would diverge from those 2 points. The
But how
horizontal
can
plane that
it
you would
if
take
those
with
two
Oh my
points
gosh!
are water, which is supposed to
Because water
conform to the
curves.
surface?
Because
But
water
how can that then be a horizontal plane, my Steve? Can't you see the contradiction?
No, there's not a contradiction.
Yeah, there is a contradiction, my Steve.
Okay, there's no contradiction to anybody who knows anything
saying
about
that
geometry.
there is a horizontal plane formed, and then claiming that diverges from your surface.
Does it diverge
you can
up
create a
or
horizontal
down?
plane.
Which way does it diverge, RC?
You ask about 2 points, you got an answer about 2 points. You ask about a
That's
tangent,
all, that's
you got an
all
answer
a
about a
water
tangent.
level is.
Stop
It's
complaining.
only got 2 ends of it. That's all a water level ever is. 2 points, one at each end. You said that's horizontal. I mean, okay, brilliant.
No, I said
where
can create a
where does
horizontal
it
plane.
diverge?
You can create a horizontal
You
plane
realize
based on those
RC
2 points
Meisty
you like.
was
And
the guy that
that's
said
the
you
answer
could
was given.
calibrate the one.
Yeah.
Oh, yeah.
So where does it diverge, RC? Does it touch at one end and then diverge, or does it diverge at both ends of it?
It's going to diverge with the created horizontal plane from those 2 points.
It is the horizontal plane. That's what we've just established.
It's not Bev.
Yeah, that's what
And he explained to you why it's
Magoon said. It creates a horizontal plane. Are you deaf or something?
said you
my
can
Steve?
create a horizontal plane. The Earth does not conform
It
to that.
does.
He says
Yes.
it does.
The Earth does not conform to that horizontal plane.
Struggling, Mark. Do you not want to
But that
send
horizontal-
somebody else
Did
in?
you miss the part where he said the Earth's surface would deviate from that created horizontal plane?
No, we just asking how
Okay,
does the
I
surface
wasn't asking you,
deviate
Bev.
from the
Bev.
horizontal plane?
I wasn't asking you. I was asking the guy who literally claimed that he didn't.
Bev
say
just
that.
said that he didn't hear
You
the
know what
thing
a
that you
canal
guys
is?
have been saying that he'd been saying.
Yeah, go on.
Did you guys not look at the picture that's been posted about 6 times?
Does it show
Definitely.
that a
It
horizontal
definitely does.
plane on it diverging away
Yes.
from the surface?
Yes.
Is that horizontal plane formed by water?
It doesn't matter how it's formed. It
Well,
shows how the
this
horizontal plane.
is the contention
Mhm.
that
No,
the
it's-
water is forming a
Does-
horizontal plane, which is what McGoon stated more than once.
You don't think
The
it does? Are we
water
contending
forms
against
a
that?
horizontal plane.
Who thinks it doesn't?
What the level? What the level?
The water level.
Water
The water
level
doesn't
is
create a horizontal
horizontal.
Plane.
Yes.
Yes.
It flows downhill. We know how
No,
water flows. Yes.
A water level forms a horizontal plane.
Mhm.
Water
Yes.
by itself does not.
What?
What?
There you go.
We obviously do not know what a water level is.
Can we get
that?
who was that?
You gotta clip that.
Wait a minute. Who
Yeah,
was
You gotta
that?
clip
You can
that.
clip that all you
Who?
want.
Yeah,
Who
yeah,
was
who was
that?
that?
Please.
Who
This is
said
their
that?
only argument. What's funny is that this is their only argument.
Was that you,
Who said
Beeble?
that?
Was it you,
Is that
Beeble?
people?
Was it
That's
Beeble?
the only argument.
Oh, you
Ball.
Such a
That's
clown.
not your wig
Nice
off.
one.
You're
He was
such an
right.
idiot.
We've all agreed that water is horizontal at a point.
No,
Oh,
it
here comes
is
Chunky
horizontal.
Butt
It's a
Boy.
tool that establishes a horizontal. 2 points, not 1, 2.
Sorry, what did you
points.
call me, Gary?
Chunky,
2
come
points.
on. What else you
Chucky.
got?
What'd you call
Hey,
me,
Bev,
Gary?
can I ask you a question?
You've shown how stupid you are so many times, Chunky. So come on, open your mouth, do it again.
Hey, Bev.
Can you
Bev,
read, Gary?
Bev, can I ask you a quick question?
Ask Paul what my name is. Maybe he can read it.
Chunky,
Hey,
you
Bev,
are tired.
can I ask you a question?
Go on, make it quick. But this isn't
If-
about me. This is more about the
if I set
horizontal plane of
If I
water.
set up, all right. If I set up a water level at 5 feet above the water,
Mm-hmm.
then I set up another water level a few miles away.
Yep.
And I sight from the first water level to the other water level.
Oh my
You
And
god.
the other
sighting.
water level is
Wait a
lower.
minute. You
Is
sighting
dark
5.
side
Needs a dark side.
All right.
Can I finish?
I'll go.
Can I
You
finish?
guys do it.
I'll get all over everybody.
Can I finish?
You need a dark shock, people.
Can I finish?
Have you got 32 times scope on that?
Can I finish, please?
You're pathetic,
So I set up a
people.
water level. Can I finish, please?
Go ahead, B-Ball. Finish up. Go ahead.
So I set up a water level 5 feet. So I set up a water level 5 feet above the water, right? And then my second water level is 5 feet above the water. Then I sight from my first water level to the other water level, but for some reason the other water level appears lower in my crosshairs. What's going on?
Refraction, atmosphere, mirage, whatever.
Yeah.
Optical
People, you're
illusion.
not sure.
That's how we call it.
It's called drop. It appears.
By the way, if we were surveyors, we would call it and write it up as a drop. Isn't that the case?
But then we'd have to account for curvature, right? Because that's what surveyors do. They account for curvature. And
No,
refraction.
you think in between the 2 points you have a curvature, but what you actually measure is just a point to point. That's a straight line, and that's why it's called drop.
that's what surveyors do. They account for curvature and refraction. Or
No,
do we
they
ignore
measure
that?
drop.
Using Euclidean geometry, of course they do, people.
Do surveyors ignore the curvature and refraction? Because if they do, they'll get an error, right?
They do it in short distances, so they don't need to do that, right?
Yeah, but we're talking about long distances.
Yeah, but we're talking about horizontals, exact measurements.
We're talking about long distances.
Yeah, but nobody does that. You don't do horizontal measurements or vertical angles over large distances, do you?
Well, surveyors that do long distances, right? They have to account for curvature and refraction.
Which surveyors are those that do long distance measurements for a horizontal or a vertical measurement?
Take a wild guess.
There is no surveyors that do that, people. None.
Right. Okay.
How do ordnance surveyor do it, Beth? How does the ordnance survey do it?
Spirit leveling. They usually use first order measurements, and have you ever looked at the distances that you do that for first order measurements?
And what shape do they think the Earth is?
Who?
The ordnance survey.
Who cares what
The
shape?
Ordnance Survey don't think anything. It's a company.
Yeah, they know
What did they conclude the Earth is?
That's why they don't think, because they know, because they've measured it.
Yeah. Yeah. What did they conclude the shape of the Earth is?
I wouldn't know. How would you think they'd do it?
Because they told you on Twitter, Bev, didn't they?
Pardon?
Yeah, they did.
They told you on Twitter.
Who told me what?
Who are we talking about, Bev? Do you forget already?
Maybe you could
Are you talking
elaborate
about
for the
somebody
audience, Brad?
who's posted to me on Twitter?
Yes.
Right, and is that what you are using as your citation? Somebody has posted something to me on Twitter.
Yes, who was that? They said the Earth was a sphere.
But boy, you're
That was the ordnance
sad.
survey.
Why are you clutching
Gary,
at straws,
Gary.
Butt boy?
I'm not clutching
Yes,
at straws. We're using experts who do this for a living.
Can I just get this one more
fucking
time?
weasel.
One more time. You are
Specifically, you're
citing
using-
a tweet as your citation.
A tweet from a
Yeah,
company that
from
surveys.
the guy-
Yeah.
That's good enough. That's good enough for me. You
A
cite
tweet from the
tweets.
guys who you are quoting, who say you are wrong.
Yes.
Who's
that's what I
saying
mean.
what?
Thank-
What did they say? in
Holy
this tweet?
fuck! This guy forgot already.
Yeah, come on.
Yeah,
How long ago was it? Have you got it marked? Go on.
It was 30
If
seconds.
was
we were
If
literally
you
just
saved
talking about it.
a tweet to me, you've saved it. Like a lot
No,
of people
WS
have
did,
said
though.
really stupid things on Twitter to me.
Does Ordnance Survey say a lot of stupid things on Twitter?
I don't know. I don't to keep up to date with them.
Do you use them as a reference at all?
The ordnance. I use the maps for the Ordnance Survey. Yes.
Yeah.
Yeah.
And you don't think they know how to survey properly?
Who said that?
Also,
what are you saying?
Do you agree with the distances on those maps, Bev?
What? Yes. The distances on the Ordnance Survey maps for the UK. Yes.
Straight lines and square boxes. Why wouldn't you agree with that, people?
Grids. Grid reference system across the entirety of the UK. Ultra accurate, to scale. Pardon?
They said they're not to scale, didn't they? They said they're distorted slightly.
They are to scale, though. That's the problem. All of the maps that we have from the UK are to scale. It's all to scale.
But they said there's an error
because somebody tweeted something that goes against that.
Can I just say something, please? They only distort when you try to put them on a spherical surface.
They don't distort maps, right? So don't even give it them. Because I'm getting said.
They will only distort.
Yeah, but they're telling me. They're telling me that there's a.
Opposite of what they said, Rob.
Never mind.
That's the opposite of what they said, Rob.
I'm glad you agree with the distances because those are distances measured over a globe.
Right, okay, so I'll say it again. This is the last time I'm going to say this, right? The maps of the UK are on a grid reference system. They are to scale. If you draw a triangle on that map in the UK, it will have 180 degrees. When they have mapped the UK, they have triangulated all of those positions to find them by drawing straight lines, right? In order to map the UK onto a grid reference system with square grids, right? Now, I'm not going to say anything other than that, because if you know how geometry works, right, and that is to scale, no distortion, there you go, full stop.
Bevan, are you saying because you... Wait. Are you saying because you flattened the map on a table and then you drew a triangle on it, and the triangle became out to all the angles were 180 degrees? Is that what you're saying?
That's definitely what I'm saying, yes.
Right. Okay.
Well done, Bev.
Well done, Bev. Good job.
You flatten out a flat piece of paper. Bebo, how do you flatten out a flat piece of paper?
In your mind, because the paper is flat, that means the Earth is flat, right?
No, I have not said anything about the Earth.
We didn't say the Earth being
the Earth is not a sphere. Let me not say the Earth is flat. We'll say the Earth is not a sphere.
Right, can I just flip this round on you since you've asked me a fair few questions now, right? Do you think because me, can flatten out a map and draw a triangle on it and that triangle will have 180 degrees, do you think that proves your globe?
No.
Good.
No, not at all.
But Ordnance Survey doesn't measure triangles with 180 degrees. They measure triangles with spherical excess.
Triangles only have 180 degrees. I'm sorry you have
Not
to say
spherical
this.
triangles. Not spherical triangles, and not the triangles measured in reality.
The problem is
only exist in your mind.
The problem is once you put a triangle on a sphere, to them, it's no longer a triangle.
It's not, because it doesn't have three lines. I mean,
we're wondering why you're talking about spheres. We're wondering why you're talking about spheres at all. What are you talking about?
Because Earth is a sphere. I'm surprised you're wondering. Is it complicated?
So therefore, triangles must have more than 180 degrees, right?
My
Yes,
model dictates.
triangles on the surface of a sphere must have more than
My
180
model
degrees.
dictates.
Nice.
No, reality dictates.
Yeah,
No, in reality, there is only 180 degrees in a triangle. Only
On a
there
spherical
only
triangle,
ever
do you
can
think?
be. There only ever can be. Where would you find a spherical triangle?
Except for the ones that have been measured on the surface of the Earth.
Where would you find a spherical triangle?
On a sphere.
Except for the
Does
ones
anyone
that
agree with that?
Where on a sphere? Where on a
Here,
sphere?
I got you.
On
Here,
the
here
surface
Earth,
of the
you can
sphere.
use,
Right,
you can use
okay.
navigation.
the surface of a sphere. What geometry do you use to geometrize the surface of a sphere? Come on, who's up for that one?
Spherical geometry. And the way that I'm explaining it, the way that I'm explaining it,
Shut
the
up.
way,
Spherical geometry.
You're not going to tell me to shut up.
The spherical geometry is the hypothetical geometry
toilet sniffer.
which
Let
involves
Theodore
the
answer.
surface of a sphere. Hypothetical.
Okay.
Is that
You're
breaking up. Are not hypothetical.
You're breaking up, bro. Try again.
Except for the ones that have been measured on the surface of this. Go ahead.
Did you not get the bit where spherical geometry is a hypothetical geometry?
It's not a
It
hypothetical
is a
hypothetical. We have
hypothetical.
spheres within
It is
reality,
a
separate from the
hypothetical
Earth.
I said it.
geometry.
I said it in the debate.
The Earth
I
would
said
be a
it in
flat
the
Earth.
Don't
Spherical
have
geometry would
spheres in reality.
We
Whoa,
don't
say
have
it again.
DP. Do you have any
Say
balls?
it again. Hold on, say it again.
What's the fucking
No, say it again.
basketball?
No. Say it again. Say we don't have spheres in reality. Say it again.
A sphere is a hypothetical surface.
No. Say it again. Say we don't have spheres in reality again. Say that.
A
Say that sentence
sphere
again.
is a hypothetical surface of a
No, it
ball.
isn't. A sphere is a
A
shape.
ball
A sphere
is
is a
a
shape. It's a
three-dimensional Euclidean shape.
Right.
Do you not
It's
have
a
any balls?
three-dimensional shape.
He is very
A sphere
precise
is a
and right
three-dimensional
about that,
shape.
by the way.
Spherical geometry is a geometry that we can use against the sphere, of course.
Hypothetically, because it only exists hypothetically.
Is anybody going to clip?
No.
Is anybody going to clip the statement saying spheres don't exist?
DP.
Is anyone going to
Hypothetically.
clip that?
Do you have any balls?
Oh, we have hypothetical spheres, so we don't have spheres in reality. Say it again.
Yeah. Say it again.
Don't have spheres in reality.
A sphere is a hypothetical surface.
DP and Travis don't have any balls.
Hey, can I have a quick question with B-ball? B-ball, can you hear me?
Yeah, can we let Travis in here?
Go ahead, man.
Okay, so I asked McToon for evidence for temperature inversion, and you responded with an article that just had rhetoric. So the evidence that I'm looking for is scientific data that demonstrates temperature inversion. So if you're not going to provide that, then don't provide anything, okay?
So are you saying that a temperature inversion doesn't exist?
Okay, again, here you go. There you go. There's the typical baller.
Fucking idiot.
There's the typical.
Posted the evidence. I mean, you can do your own research.
Okay, look.
I'm not going to do your research for you. I mean, even though I do most of the time.
Trained right from paid NASA skills playbook. Go ahead, say it again.
Hold on. Again, B-ball.
Oh my goodness.
If then, was that a logic?
That's logic. If you are religious to Christianity, you can't trust him on science. Can you?
Wow. Can't have
His
two religions.
His mind's fallible to fiction. So anything that he preaches during the debate could also be a fictitious belief.
Don't think he's going to be preaching.
Dawn,
at least you guys know.
If you could try and stay back from the mic about another inch or so. You sound like you're eating it.
Testing, sorry.
It's good to see everybody's come back. They all left this morning, didn't they? Has everyone come for the debate? Isn't it exciting?
I am a wee bit.
What do you want to do? Do you want to like start it at the beginning and then you do an introduction and all of
that? Sure.
Yeah. And if you want to take control, I mean, that's the idea of this place. Hopefully, should be it's an arena where everyone can come together and you can do your stuff, right? So all we're doing is facilitating a place where it's got maximum boost on this Discord server. It's got great, you can get 1080p sharing screens, and it's got the best sound.
It is. It's excellent. Yeah, I'm really impressed. Discord's been great, and this server's really cool too. It's impressive.
So hopefully what we'll do when it comes around at 5 o'clock, is it, in about 25 minutes, we will mute everyone by you and try and keep an eye on people entering the room, and we'll mute them.
Okay.
If anything occurs that somebody does manage to sneak through and say something, we will just literally mute them, not say anything. We'll just mute them and keep putting it in the chat that everyone, because this is the first time this has ever happened on this server, and obviously there's a lot of people that don't know what's going on around here, so we'll just we'll just mute that, and we'll keep putting, this is a debate with McToons and What's Up, Amy moderating, that's it, only them talking. So if you want to do all of the presentation, now it is normally live streamed onto YouTube, but for some reason both of the live streams are down at the minute. We've had a word with Geo. Hopefully we can get them back up again, but
he's good at that. He usually gets them back up, Amy. But
okay,
you're able to post stuff, and you have everything you need.
We do, thank you. MC Toon's going to help out with that as well. He's got everything all situated as well, so he's going to be able to maybe even stream it on his, or just even record it and put it up on his later.
Yeah,
Bev, I was going to say, couldn't you stream it from yours?
I could if it needed to be done, but I mean, like I say, Geo is normally going to hopefully he's going to get the streams back active again.
Excellent.
And McToon will do his own stuff anyway, right? Yeah, like you say, he'll either record it or put it out live, whatever.
Exactly. So hopefully we can get one or the other to work.
Hopefully this can start a new thing, right? We should be able to be hosting these type of events quite often, I think.
I think so. I think it's a great idea, and people love them. We've noticed that when we've had them on the shills. We're paused right now because everybody's having some life issues. I had some time today because my son is in school. He's on the spectrum, and so I've been working on his disability determination and everything. So, but once all that's settled and everything settles down, we can probably start doing that again too. Because I mean, everybody loves them. They love the debates, and
I don't. I hate them.
Yeah. And it can be just a discussion as long as it's, one-on-one or two-on-two without the audience interrupting. I think that's what we're going towards more. It doesn't have to be a full-on, debate with huge amount of rules or anything. Just that civil discussion where each point gets out with an audience.
Absolutely.
So why aren't we doing this as a staged event where we just listen?
Because on the stage you cannot share your screen or camera. It's
We're
a little bit of a bug at the minute they've not upgraded the stage to make that available for presentations yet, unfortunately.
This is going to be basically the same, though, where the audience is muted. I mean, it's basically the same.
Yeah, we just got to exercise mic discipline for everybody. And, of course, y'all having control of the mute, they take care of that.
There is actually a bot that mutes everybody in the room, so that will probably be the best option, and then just to unmute the three that are going to be speaking. That's it.
Sure.
Amy, as a Glober, how do I trust McToon if he believes in Jesus?
Dawn, it's the moderator, please.
Yeah, and why are you asking her
That's
questions
not why
about
Amy's here.
him? Yeah, you need to ask
for him.
Yeah, but you need to ask him.
Yeah. If she's moderating for him, she's speaking for him.
No, she's just moderating.
She's here to explain everything about McToon.
Just moderating.
Oh, okay.
Amy.
No, I'm just moderating the debate. That's all I do.
Amy, have you got any opinions on this? How do I trust McToon if he believes in Jesus?
Everybody is different, and I'll explain it this way. Everyone is different. They all have their own beliefs in everything.
So
It's up
McToon's
to you to answer
just
for
like
it to
everyone
you.
else. He's got beliefs. He's just like flat earthers with beliefs. Is that what you're saying?
Everybody
Yeah,
has
he-
beliefs of some
Okay,
sort.
so McToon is just like the flat earthers, everyone. He just has beliefs.
Dawn.
Yeah, why are you poisoning the well?
Well done.
Yeah, nicely done, Howard. Well done. Yes, definitely,
Yeah,
Dawn.
it's
Please
all right.
stop doing that.
It's just
Yeah,
a few questions before the debate. I'm interested in one of the participants.
Yeah, no problem.
How would I trust him as a glober?
You should be interested in the arguments, not the
No,
people.
I'm not interested in any of the arguments. God, no.
Oh. I'm not sure
But
why
that's
you
what
were here.
Earth versus religious science. Why would I be interested in the argument?
Why are you here?
Talk about McToon.
I know, but there's going to be a debate happening
About
soon.
McToon.
So.
I know,
That's not the debate topic. I'm sorry.
Yeah.
That's not the debate.
Soon there'll be a debate happening. Amy, let me just tell you, I know you come up with one idea. Maybe I should trust him because everyone is different and everyone has beliefs. That's not enough. I don't trust flat
Okay,
earthers
Don,
for
you
that
know what?
reason. So I won't
You
trust
can have
McToon
a
for that
debate
reason. I would never trust him, Amy.
After
That's what
I
I'm
have a
telling you.
debate with McToon.
Ever.
And you can have a debate with Amy about McToon, and I will moderate it. How about that?
I'm all set, thank you.
No, there's no debate. It's my truth. No debate. Well, and also, thanks to McToon, we now know that homeschooling is good for children. So no glober can ever argue that again.
I don't think they do, Dawn.
Yes, they do, Bev. You've seen them on Twitter. I've seen you see them on Twitter.
Oh, well, Twitter. You know how Twitter is.
Yeah, I've seen you
It's
on
called
there.
a different
Amy.
word for a reason.
I've seen you on there bullying people.
Oh, you have? Okay. Yeah, I'm on Twitter once every 6 months.
Dawn checks up
But
on
okay.
you, though.
Yeah, that's great.
Bullying people for wrong think.
Oh, I see.
Not like you doing, Greg, at the minute, Dawn, right? Somebody doesn't think like you do. So you're questioning them.
No, we've
About
agreed.
somebody
McToon thinks
else's
flat
beliefs.
earthers. We've agreed this. We're all different and we all just have beliefs.
Mhm.
McToon is like a flat earther now.
Yeah, we're all the same, Dawn, basically. We can all actually
We're
think
human.
whatever we want.
Exactly, humans
none
with
of
free
your
will.
You can believe in
concern.
Jesus Christ, you can homeschool your kids, and then you can expect to not be trusted by me ever.
Okay,
Alrighty.
brilliant. That is expected. Anyone can do whatever they want, Dawn. There's no need for you to tell everybody.
You're defending your enemy now, Bev.
It's not an enemy. I don't have enemies like that, Dawn.
Make silly memes and videos about him, then calling him names.
Excuse me, it's me that makes the silly memes.
We just laugh about stuff, Dawn. I know you get upset about it.
And when they
No
say,
big
when
deal.
they say, oi, Dawn, when they say and do stupid shit, they're bound to get memed, aren't they?
And that goes for both sides.
Now I attack them with you.
Absolutely.
Bev's defending them.
I'm defending people's rights to think whatever they want without being punished or told.
Defend the right
Dawn
to have a fake
doesn't like
debate
it.
with someone that doesn't care about you.
My goodness, Dawn.
Amy, it's all a charade. You're a part of it.
Yep.
MC Toon in the house.
Yay!
Okay, I'm out. McToon, you're a religious hypocrite.
Oh, you gone?
Oh my.
Is that it? You've got your chance to ask all the questions and everything now, Dawn, before the debate, right?
Oh, can I?
Well, I don't know.
I think.
Oh, really?
Well, he's okay to say no, right?
Yeah, he can say no.
McToon, why should I ever trust you as a glober if you believe in Jesus?
Number one, I don't care if you trust me or not.
There we go.
Why would
So-
anyone? No, why should anyone? That's the question. Why should anybody as a glober trust you if you believe in Jesus?
I don't see how it makes any difference. I guess if you thought it made a difference, you could suggest why.
Jesus is a fictional religious belief. That's why it makes a difference.
Well, it's certainly a lot of people do think that.
You're fallible to fiction, and now you want to preach science.
Hang on, Dawn. I
That's
thought it
being a
was more.
hypocrite.
Dawn, I thought it was more the contradiction between his religious belief and his faith in science.
No,
that
it's not the contradiction. It's him thinking he's smart and intelligent with facts while being fallible to religious fiction. Completely hypocritical.
The floor's yours, MC Toon.
Oh, that's his opinion. I mean, what do I have?
It's a fact,
It's
bruv.
just an opinion.
It's hypocritical, whether you like it or not.
Don't take him seriously.
You accept it or not.
He's just trying to wind you up.
Yeah,
Mega
I don't,
hypocrite. Mega
I don't
hypocrite.
take Don seriously. No, I don't think anybody really does. I mean, we all know he's
Okay,
just
good.
trying to stir things up.
Look, Toon, can we agree that homeschooling is fine for kids?
Oh, yeah, I think it's great.
Right. So when your global friends try and bully people about homeschooling, can you help and tell them, no, it's fine. You shouldn't bully people about that.
I generally do.
I've never seen you.
Privately. Yeah, unless you're hacking my private messages, you
I
wouldn't
don't
see
even
it.
see you mention it, honestly. You're always shilling for science.
I think we're
many
getting into a personal thing now, right? These are personal issues, right?
Oh, it certainly is, yeah.
So, McTurin, when you go forth in this debate, I just want to tell you now, it's all fake. You don't care. You're just shilling for YouTube clicks, and you're a hypocrite. So nothing you
Wonderful.
say means
I hope you
anything.
feel better now after saying that, Dawn.
Thanks,
Thank
John.
you very much.
Thanks, John. Move along.
Yeah, I think we've had enough of that, Dawn. You can be unmuted after.
Thank you.
Yes, thank you.
So I'll go over it with Toon again as well then, right? What we're going to do is whenever you want to guys start the debate, we'll mute the entire room, unmute you guys, and then we will hopefully keep a check on anybody entering and trying to talk. If anybody does talk, we will just mute them. We won't bother saying, sorry, we didn't. We'll just mute them. So you guys just carry on with what you've got to do. And that'll be the way that this place will do it. Like I said before, it usually is being live streamed, but I don't think it is at the minute. I don't think we're back live yet. So if you want to have any sort of record of this, you obviously going to record it yourself anyway.
Yeah.
What
Hey,
I
Beth,
will
can I
do
make a
as well,
suggestion?
if it's not running, I will also follow you guys round on your live streams so that we can record the live streams as you're talking about them. And record that if it's not back up, because it won't go up on this server with all of those switches.
Okay.
So I will follow you guys
Bev,
around
can I
and do that.
Can I make a suggestion? Had you considered using the stage?
You can't.
And that way you can.
You can't.
Okay.
There's no sharing your screen or camera on the stage. It's not
got
been
that.
fully implemented into the program yet, so that's why we're having to do it like this. And like I say as well, this is the first time we've done this on this server, and I think it's the first time so we'll try and do it as good as we can. But yeah, that'll be the system. Just Amy, McToon, and What's Up unmuted. We'll try and keep everybody else going, and you guys just go until you're done. At that point, Amy will take over and do the introductions and all of that sort of stuff. Does that sound good with everybody?
Good with me.
Awesome.
Yes.
And everybody else in the room, obviously, no talking.
Can I test sharing my screen here quick?
Yeah, it should be. If it's on the screen at the bottom, you should be able to do it.
So, do you see that?
Yes, flat. Let's
Okay.
have a look.
Yes.
Okay, so that's
Perfect.
good for me. And obviously, because he's got all of the boosts to this server, you've got the 1080p live stream availability and the upgraded sound quality, which does sound brilliant. If you've got a good mic, this is one of the best Discord servers I think I've ever heard.
Excellent. That's awesome.
And we can ask everyone, I don't know if you want to use the live stream to text chat. Will you be using the text chat a lot to put pictures up, or will you be using your live streams to do that?
I like to provide links, so I might put stuff there.
Okay, well, this is just for everybody else that's in the room. They'll be posting all sorts of stuff, right? If somebody's posting links, can you try not to put loads of spam text in there and move the link up off the page if that's what's being referred to?
Okay. Sounds good.
Hey, and Bev, just to clarify, do you want to server mute everybody?
We will do. There is a server mute all button that we can mute everybody and then unmute the people that need.
Yeah, and we only need one person doing it. Otherwise, if everybody's trying to do it at the same time.
Yeah, and I'd hand that over to Emma.
Yeah, I'll be in charge of that today.
Can't blame me.
As little blame as possible. That's what I try to do in my household.
I'd like to thank you for coming over here, though. This was a change of venue, as I heard. And yeah, I'd like to thank you for doing this, because we're hopefully this is where we should be doing these sort of things. You know, everybody can come over here. There's loads of Globers and Flat Earthers and others around here.
Yeah. So thank you for having us too. This is great. This is going to be really good.
That's what I also wanted to say. You're very good sports, both of you.
Thank you.
Yeah, thanks. I got no problem being on any platform as long as it's fair. And so far, this has been very fair.
Yeah, but it's the same for me. Yeah, exactly.
Exactly. So this is great. And this is a great platform.
So when do you want to do it? And start in 5 minutes. Everybody go and get your cups of tea ready, and we'll get.
Can I ask what's happening, please? What's going on? What's going down?
What's up? Oh yeah, that's a good one. Before we start, right? What is the debate about? What do you guys expect? The format of the debate. Can you let us know that? Like Spot On says.
Yeah, domestic is given a
today. Yep. Sorry.
I think he was asking you. I'm sorry, but domestic is doing an hour-long presentation, and then y'all are doing a debate, right?
That's the basic idea, of course. And for the change of the game today, I'm gonna be starting it.
Who's
the
domestic
topic?
I know he's got the wrong person. Don't worry.
Okay.
So yeah, the basic idea that we had for last time was also measurements of the main sea level.
Excellent.
So that's gonna be the basic topic today, and from there we are gonna branch out. If we are gonna branch out.
Excellent. Perfect.
Are we on the same page on that, Macton, by the way? Before
yeah, that's right.
Oh, okay, great. Yeah, okay.
So, did someone mention an hour? Someone's going to do an hour presentation, or is that a joke?
So it's not gonna be an hour presentation. It's just I'm gonna start it, I'm gonna present it, and probably I'm gonna hear that I'm a stupid one again. So that's it basically.
Yeah, no worries.
Question: is it scone or scone?
It's scone, but my daughter would argue and say it's scone. So there's even an argument over here.
I've heard Paul Hollywood say scone, and then whatever Prue say scone.
Well, Prue is the sort of very upper class, posh British, and yes, it would be scone. But if you're hanging around with your mates and you come out with that, they probably laugh at you.
Oh,
It's
wow.
scone. Yeah. So I guess if you were dining with the Queen, it's a scone.
This is where I would come in and say, is it done or don't?
I know, but is it cone or
Right.
you can do this for days.
Right.
Travis? No, it sounds like it was Travis.
As long as people agree what the
was him.
scone or scone is, then that's fine by me. It's when people say things like level and think they're curved. That's like a different.
Ooh, don't start
meaning
that
to
yet.
the
No,
same.
no, no. That's my job today.
Oh, sorry, I didn't mean to come in there.
I'm just kidding.
Spoiler alert. You change the pronunciation of the word, but you can't change the meaning of the word, is what I'm saying.
Is this just going to be a debate about what level is?
About what?
Is this going to be just a debate about what level is?
I don't know. That's might be what's up is. It depends what direction he goes, I suppose.
You said you're talking about sea level, yeah?
I think that
New
is
sea level measurements. Yeah.
Don't give away too much.
Basic
I've given away way too much already by the sounds of it, so I'll just sit back.
I'm ready whenever anybody else is.
Okay, just bear with me. I'm going to mute everybody and then mute you guys individually.
Including me?
Yeah. Everybody.
Do you know who I am?
Let's see if it works.
I know, and that's why you are getting muted, by the way. Just so you know.
It's not working.
I can still talk.
Yeah, I've just pressed it and it's not working.
Ooh.
M is mute. And
Well, just everyone mute up. It's simple, isn't it? Oh, you want the absolute control, right? Yeah.
It seemed like Geo was trying, experimenting with it, and it was sort of slow to react, but it eventually worked. But maybe it's not now.
It's still got M2 and U already clicked. Now, it might be because they're already clicked that we can't, so we might have to just go through and mute everybody. But
Mute everybody.
everybody, from now, please be restrained.
Yeah, mute yourselves, otherwise we'll mute you.
Yes, I'm going on mute, and I will remain so until the debate's over.
Awesome. Thank you.
Thank you.
Okay, we can start whenever you're ready, whenever you're set up, MC. And
I'm
what's
ready.
up?
I'm ready right now.
Alrighty. Cool. So we're gonna start. Welcome everyone.
Yeah.
Okay. Awesome.
Paul, listen, even if you don't think that I've done enough research, I've done enough research to know the rhetoric, and all you did was post rhetoric. You did not post evidence.
So is the rhetoric incorrect? Is that what you're saying?
No, I want to know what the rhetoric is based on. I want to see the scientific data that the rhetoric that everybody else I have. That's why I asked for Toon, because the dude is so prolific with all of his citations. That's why I addressed him. That's all.
So you're asking me to do your research for you? Is that what you're saying?
Okay, fuckwit. I didn't ask you to do
No,
anything.
wait.
This is nice. The moderation here is amazing. Fucking retards calling other fuckwits.
Okay, look, I didn't ask.
Fuck off, retard.
I didn't ask you to do anything.
Wow.
I asked.
Come on, guys. Let's not do this. We were doing very good. Both sides. Chill.
Who questioned the
Please.
mod as I was DMing him about that? Who did that verbally in
Hey,
VC?
if you did,
Here,
good job.
here, I'll put my
I'm
name out
just
there.
asking
Travis is a
I'm just
fuckwit
asking
mod.
a simple
Travis is
question.
a fuckwit mod. Said by
mod
BioDual. He's a
just
fuckwit mod.
talking and
It
asking a
was
simple
one dry
question.
potato.
As I was modding, who questioned the mod and called out
We
names?
did because we didn't know. We didn't know you were doing that in the background, right?
That's damn right you don't know. So why are you questioning it?
Appreciate it. Well,
Thank
you. We
you.
appreciate it.
Because when regular people are modded, we know it's
shut up.
publicly in the
Be quiet.
VC.
Listen,
When
I
mods do it,
apologize.
it's a slap on the wrist.
We do the mods.
I
how we
was
see
server
fit.
muted earlier, so calm
When
down,
you
balls.
complain about the mods,
Yeah, we
you
all
get
were.
immediately muted. Got it? Can you remember that from day to day? It's not that hard. I think
Found
some of you have a comprehension problem, and when you come in here, you think you can act like you want. You cannot. There are rules
That goes
here
to both
that
sides,
are
right?
very. Not talking over a mod is one of them. Got it? Should I have to say that more than once?
Yeah, I'll just jump in and
Thanks.
apologize. I do apologize for breaking the rules. I do apologize.
Read your DM, please.
Yeah, let's have domesticated primate apologize for that too.
Let's have people worry about themselves and not do personal stuff. Again, I'll repeat it again for the slow and impaired. That I'm not making fun of. I'm just saying may exist and can't follow simple instructions. Stop the personal crap. Not here.
Yeah, can I just add? It's been nice, but it's sort of changed a bit to what we normally used to. But thanks for keeping quiet and doing all of that and helping us out with the debate thing. We hope to try and get some more.
Yeah, that was great.
I'm gonna.
I do appreciate everyone what they did. I mean, we had a few interruptions, but I think they didn't know.
Yeah,
and everyone else really respected it. That's great. We only had to put a couple of people on mute that probably didn't even know. So
yeah, so like for next time, I mean, this will be going out as a recording. I hope Geo managed to get the thingy recording again and doing it. But if not, I'll send him the recording of this. Then he can put it up on the site anyway, right? So if this is ever happening again, like, can we get people to just come in and assess what the conversation's going on before jumping in? Because it may be another one of these debate situations, right? And if two people are having a debate, it's better to keep it so nobody clips in and starts jumping in on it. I mean, everybody does get excited, we know that. But at times, can we have it that nobody jumps in?
Yeah, I think
I'd like to say, I thought this server was where we could just jump in.
Yeah, you
Most
didn't
of
do
the time
anything
we
wrong,
just
Rob.
come in. I came in and I got shit on as soon as I opened my microphone.
No,
I didn't
no,
know that there was a closed debate going.
Yeah, no, I don't think anybody said
want people
anything.
doing it on purpose.
That was McTooney. We told them at the beginning, if anybody comes in, we'll just mute them, and that's it. McToon shouldn't have done
I was
that.
okay with that.
Yeah, but it was McToon that did that.
And
You're
then
right.
as soon,
yeah,
and then as soon as the debate was over, I got unmuted. So.
Yeah.
Right,
It's all good. I love this survey, by the way.
Yeah, I got muted during the debate. I'm not sure why.
Yeah, so did I.
And it was a great debate, and I do thank everyone for their patience. They all did a wonderful job, and nobody did anything wrong, just so you know. I just thought it was amazing that everyone was so cooperative and did such a great job. So thank you.
Next,
You did
good. Amy, next
Yeah, you
time
did
you
good.
speak to McToon, can you ask him why he quit? Why I didn't get an answer to my question?
Oh, okay.
because of
Domesticated primate, is that you that was just speaking now?
Yeah.
Yeah. Okay, yeah, I'll let him know.
Right.
Yeah.
Next time I see him, yeah, because I'm sure I'll see him in there.
I'd like an answer to my question. You know, I feel it was a fair, reasonable question, and he just ran away from it. So I'd like an
He
answer
might
to
he
it.
might have left for other reasons. Who knows? He's pretty open about answering things, even if he says things we don't agree with. So I don't think he's avoiding your question, maybe, but just got tired and wanted to get out. That was a good time to leave. It did seem to me he was avoiding, but I don't think that's just not in his character. He would use a tactic or whatever. I'll tell you what, he's great. Like, he could take our argument and win the debate. You know what I'm saying? He's that good at debating using the tactics that he uses. But the personal stuff that he gets into, this is high school. It's just demeaning, right? I think he's he's intelligent enough, or he has a good enough intellect to not use that tactic. We all know it's a tactic, and it just really turns people off. You might want to relay that.
Okay, I will. Thank you.
You understand what I'm saying, right, Amy? When you say, this is third grade material, right? You're basically telling the audience that my opponent doesn't have a third grade level intellect, and it's really,
I get that.
Not any reason to use it, We try not to do that here.
Exactly. And it really went well. I think everybody did really well. Thank you, Emma. Yeah, it really went very well, and everybody, stayed polite and kind and everything, and everybody's been gracious here too. So thank you for that, and thank you for the help earlier too. I appreciate it.
Yeah, no problem. I mean, this server is set some standards that we're trying to uphold to, and that's why I do get upset, because the same people here can hold a civil conversation for hours, but sometimes they choose not to. They know personally I'm trying to be fair, yet don't, give the respect to a mod, no matter who it be. It's not a person. A mod is a controller, not a person. So I'm not sure why intelligent people can't recognize that and just act accordingly. But we'll work on that. It's a long process.
Yeah.
So.
It is.
Might I add something to that very quickly?
Sure, go ahead.
Can I add something to that? Okay, thank you. So, what I wanted to say is that I know it's naive. I know what I'm gonna say is naive, okay? But in my opinion, this should be like a little, how do you call it? So reference point to the future as to how things can be done for 2 hours at least. Because in my opinion, yeah, it was surprising that it went on for 2 hours with such calmness and civilness. That was surprising even for me, by the way.
Yeah. I texted Amy and I was like, yeah, they're getting a little anxious. Maybe it's a good time to end on a good note, because, you could hear it in each of y'all's voices, and it wasn't just one.
Right.
I don't think anybody did anything wrong other than Mattoon using that tactic of trying to demean. He might not even realize that's what he's doing, or that's how it comes off. It might not be intentionally, but he does it so often it does seem so, and it really does throw off your opponent. I know that. I mean, this is debate 101 basically. So
absolutely.
Anyway,
what about the purposeful tactic of interrupting him? And then when he says, if you do that again, I'm going to leave. So you immediately do it again. So he leaves. Should that tactic be called out too?
Yeah,
I'm calling him stupid.
Yeah, that's a bit bad of McToon's to do that. But so, yeah, I'd call that out if he does it again next time.
But everyone kind of does some things. It's when it's intentionally done to disrupt the other, or to tell the audience, like project something onto the audience instead of just providing your your knowledge about the subject. You're using tactics to persuade the audience. That is when it's not not a good thing. It's a debate tactic. That's all it is. Win at all costs. So I don't know.
Well, thank you again for everything. So I appreciate that. And I'll talk to you guys soon. I've got a kiddo home. So I'll talk to you all soon. Thank you.
Thank you. And again,
Awesome. Have a good day.
Yeah, thank you.
remember us
too.
next
Pleasure,
time you
Amy.
want to do a
weren't-
debate.
You weren't that bad yourself, Amy, by the way. You did pretty good too.
Thank you. That was actually my first debate moderating. So I'm hoping that the full one anyway. So thank you.
Yeah, thanks, guys. That was a good one. It should be good.
Yeah,
for
let's
the
hope we get
server.
more of those.
Yeah, it should be good for the server.
If we can
Yeah,
make
that
sure
was
the
good.
live streams are running.
Yeah. Well, I'll have to give him this recording.
Yeah. Bad timing. It's gone down. Geo's not around, and it's just typical technology.
Hey, I'll be happy if you get a video of the last 5 minutes. That's all I want.
Well, there's a few bits that'll need clipping out of that.
I missed the actual, like, I literally stepped away for a minute, came back, and he'd gone. So I have no idea what happened.
DP asked him a
Yeah,
question.
he snatched his own wig off.
You're bigger than that, Rob. There's no need to say that, is there?
Is that skillful? Trying to moderate.
No, I was just saying.
So, should we? Well, I don't know. Is Brandon going live tonight? Because I was going to do something over here anyway, but that was a good debate. It's a good start. Was anyone?
I haven't seen anyone